Great start. Thank you, everyone. It's nice. It's nice to be back in the Iron Age. For me, it's really a great pleasure to have the opportunity this morning to introduce this session on the Iron Age, a topic that's dear to my heart. And I would like to take the opportunity to introduce the first speaker, Dr. Maria del Carmen de Cerro Linares, who's going to speak about the metal finds from Almadam. Thank you very much.
Thank you, Peter. Good morning, everyone. Thanks you for sharing your time with Tatiana, Carlos, and myself today. We try to present. I must to do it, or the presentation is. Okay. To present you this short preliminary study about metal finds at Almadam. The Almadam Plain is one of the most significant archaeological landscapes in the central region of Emirate of Sharjah, located in Southeast Arabia, close to the border with Oman. It traced during proto-historic periods from the rich alluvial deposit that sloped from the higher mountains. The plain has been the focus of extensive interdisciplinary research since early 19th. Initially, the research was led by a French mission, which became a collaboration with a Spanish team in 1994. 2 years later, the mission was solely Spanish, and our research has since focused on several sectors of Almadam, and since 2020 also in Al Hudeira, which leads in the same region, central region of Sharjah, 30 kilometers north from Almadam. Some years after, Thuqueba has evolved as a complex oasis settlement system that flourished during the Iron Age. The site strategic location, bordered by Oman Mountains to the east and protected from the encroaching desert dunes by the Jebel Buhais and Jebel Malach, enabled the development of a vibrant agricultural and pastoral community around 3 millennia ago. The area is steppe spring with trees and dotted with cultivated fields and palm groves. Archaeological investigation at Almadam Thuqueba has uncovered a well-preserved Iron Age settlement characterized by large mud brick houses, communal spaces, and the evidence of both farming and animal husbandry. Thuqueba's state of preservation is excellent thanks to the protection afforded by the surrounding dunes. These houses, constructed with large, durable mud brick made from local bedrock, sand, and gravel, reflects the inhabitants' adaptation to the environment and their mastery of the available resource. All this way of life was supported by a sophisticated water management system, including wells and underground galleries that we call here flats. Since 2002, the Spanish mission has confirmed the existence of at least one falat in the area and its links with the Iron Age village. Today, the falat of Almadam, which is in Sector 2, is one of the best known Iron Age falats in the Oman Peninsula. The evidence indicates that the Iron Age people of Almadam conduct groundwater to their fields through tunnels, channels, pots, and pits. Almadam inhabitants knew how to maximize the potential of their environment, combining agriculture, cattle breeding, trade, and hunting. The settlement's prosperity was closely linked to its ability to exploit a high water table through the construction of deep wells and water galleries, which ensure the continuity of agriculture and daily life in a challenging environment. These components highlight the technological ingenuity of its inhabitants. The Iron Age occupation of Almadam is further distinguished by its material culture, including pottery, tools, and a diverse assemblage of metal artifacts. These metal objects, ranging from utilitarian tools to weapons and ornaments, offer critical insight into the technological capabilities, resource procurement strategies, and a social organization of the community with the region, which we will assess in this study. Previous studies have emphasized the importance of the metallurgy in the region, particularly in relation to the broader networks of exchange and cultural interaction that links Southeast Arabia with neighboring regions such as Mesopotamia and Iran. However, much remains to be understood, particularly for the period in study. Although Southeast Arabia and the Higher Mountains are recognized as one of the world's oldest and most prolific copper-producing regions, the organization and social implication of Iron Age metallurgy are still only partially understood. Early research focused primarily on the extraction and smelting of copper ores, particularly during the Bronze Age. But recent discoveries, such as extensive workshop at Saruk al-Hadid and Uqat al-Bakra, demonstrate that Iron Age communities develop new, complex forms of metal production, recycling, and exchange that are only now being systematically documented. Even though the assemblage of Thukeiba is relatively small, 41 metal objects and 21 metal samples, we compare to the ones in the region. The systematic collection of analytical data is imperative at all sites, regardless of the size of its assemblage. The study aimed to address key questions regarding to the nature of the alloying practice, the source of the raw materials, and the technological choice made by the Iron Age craft people at Al-Madam. By integrating this analytical data with the site archaeological context and broader regional knowledge, we hope this research contributes to a deeper understanding of Iron Age metallurgy in Southeast Arabia and its role within the oasis culture of Al-Madam. A total of 21 copper alloy artifacts from the Iron Age settlement of Al-Madam Thukeiba, we considered 4 metallurgical analyses. Of these, 19, that you can see in green in the table, was selected for based on their preservation or typological diversity and or archaeological context. Most of them, of these copper alloy artifacts, were recovered from the central segmental area that we know as Sector 1, Al-Madam 1. The analyzed assemblage include a representative range of object types commonly found in Iron Age context in Southeast Arabia. Arrowheads, the majority of the sample objects were arrowheads, reflecting their abundance and typology diversity at the site. Awls and needles that we took thinking on the utilitary pool production. Bracelet or sample representing personal adornments. Melting drop and ingot fragments that we analyzed to understand metalworking device and recycling practice. A probably blade was included to assess weapon tool alloy practice. An indeterminate object that we analyzed to capture the compositional variability. To investigate the composition and the origins of the metal artifacts from Al-Madam, as mentioned, 2 scientific techniques were employed. Inductive coupled plasma analysis and lead isotope analysis to investigate their elemental composition and provenance. Each method offers unique insight into the technological and economic choices of Iron Age craftspeople at the site. While ICP uncovers how objects were made and what technological strategies were employed, A reveals where the raw materials came from and how far the settlement connection extended. Together, both of them provide a comprehensive picture of the Iron Age metallurgy at Azuqueiba. The elemental composition of Iron Age artifact in Emirates reveals a strong preference for high pure copper, particularly in weapon types such as arrowheads, which often exceed 95% copper content. This aligns with recent archaeometallurgical research in Southeast Arabia and Oman, which has shown the local metallurgists frequently use natural copper alloys or nearly pure copper for tool and weapons production, rather the classic copper-thin bronze alloys common in the Near East and Mediterranean areas. The generally low and variable tin content, often below 0.1% in arrowheads, suggests that tin was not intentionally added, but may reflect incidental recycling or trace contamination, as there are no known tin sources in the region. Higher tin levels, up to 3% in some metal seas, I showed you like this. Let's dig M225, indicate occasional use of bronze, but these values are still below the typical 10-12% tin found in the canonical bronze, again pointing out to recycling or accidental alloying. However, trace elements such iron, sulfur, arsenic, nickel, and cobalt are present in minor amounts, consistent with the use of sulfidic copper ores from higher mountains of Oman. Lead is present at low concentration in most samples, but a few artifacts present a different composition. I come back here. M225 has high zins and tin, and M244 with higher tin and lead, and an isotopic signature close to Balkan or Anatolian files. Might reflect the use of recycled or imported metal, possibility from Iran or more distant regions. The presence of the red brass in M225 is especially suggestive of Iranian connection, as similar alloys have been found in the 3rd millennium in context in Iran. Since it's rare in Arabia, but has been documented in Iranian context. This combined with the high tin and low iron in M225 may suggest either an importance from Iran of the use of recycling of imported metal. The chemical and isotopic data together provide a strong production, but still include limited import or recycling for foreign metal. This pattern suggests that the ancient craftspeople in Southeast Arabia made deliberate technological choice based on both the properties of available raw materials and the functional requirements of the finished object. The selective use of high pure copper of weapons and more variable alloys for vexel and utilitarian items highlight a sophisticated empirical understanding of metallurgy and an ability to adapt production techniques to the local resource and cultural needs. To conclude, the study of the metal object from Azuqueiba provides valuable insight into the technological capabilities, economic networks, and social organization of Iron Age communities in Southeast Arabia. Through this analysis, we move beyond typological classification to explore the decision made by the ancient craft people, the access to the raw material, the participation in wider regional exchange system, and their strategies for producing and recycling metal. This investigation not only refines our understanding of local production and trade, but also underscores the dynamic nature of the technological adaptation with the challenging desert environment of the Oman Peninsula during the Iron Age. Thank you.
Thank you very much for this detailed presentation, and also thank you very much for keeping to time. You see, I took over the session chair because Peter had other things to do. Are there any questions to Maria about metal production, anything? There's a microphone.
Sí, hola. Only one thing, I can see the arrowhead with inscriptions. Is from the Iron Age, or maybe reuse this arrowhead? What do you think?
With the cross.
Yes.
We found this in the houses in a complete level of Iron Age.
Okay.
There's another question.
I'm just asking out of ignorance, but the strange sort of bullhorn-shaped stick, copper stick you had, it looked like there were some possible inscriptions or a couple of signs on it. Did you look at that? I'm not sure. I'm not certain, but it just looked like something.
I don't know what.
We showed a picture of this one.
Yeah, but this is a.
The writing on it.
No, this is not. There is some decoration, but it's not writing. It's decoration, but no, it's not writing. No, it's decoration. It says incision, but not deco. Is some sort of some.
Okay, so you've been looking into it.
Can I put
You
it?
looked into it. Okay, good.
We can see the picture if you like. They are going to. Can I try? I asked for to put again the picture.
I think you have to put it on the shifter.
No, they say to me that I must wait a little bit because they charge the other one. Now, can I?
Yeah.
This one?
In the upper
Yeah,
one.
it's decoration. It's not writing.
These kind of signs are also present in some Iron Age pottery, such as in Rumeila, for example, or Bida bin Saud. These kind of signs are very present as well. But we are not sure actually about the potential significance of them. So I think it needs further study in the future, inshallah. Thank you.
We found two of these objects in two different houses. Well, we found one, our mission, and the other one was founded by the previous local team.
There's one question over there.
Yeah, thanks. Regarding to these two tools, actually we found two similar to them in Sarug al-Hadid in the metal hoards, but ours has inscription, not inscriptions, actually decorations in the handles, which has like motifs of floral decorations. I think they are similar to this. The question is, what was the function of this kind of tools? Because actually we found them with another tools from our study. We think that they were used in the metallurgy industry. I think so. Thanks. Or charcoal production, because we found it actually in charcoal area at Sarug al-Hadid, actually, where we found this hoard of metals objects. With this metal hoards, we found two tools exactly like this. But ours has inscriptions and decorations in the handles. It has floral decoration. We think from our interpretation that this kind of tools were used in the charcoal productions. That's it. Thank you.
I'm very happy to know that somebody has something like this because we have this subject from a long time, from 1995. I am looking for a lot of sites and even in books, but I have not found nothing similar like this. So I'm really very happy to know that you have another one, another two ones. We found this in the dwellings, in the houses, without any connection with any more than daily life.
I think we have to move on to the next speaker.
Thank you very much.
Thank you very much again for presenting. Our next speaker will be Fausto Maro, and he's talking about revisiting predictive modeling through fieldwork. Please.
Thank you very much. Well, that's funny because she's my supervisor now, so I hope she has a nice question later. Good morning, everyone. So this next back, all right? And it's my laptop with the script, all right? Well, that's fine. So here we are. First of all, I would like to thank here the organizer for accepting my paper and for hosting us and the conference in such beautiful location, really. Today, I want to talk to you about the archaeological predictive modeling I'm trying actually to develop for the later Iron Age in Oman. Let me start by clarifying something. Too close? Right, sorry. What I mean with later Iron Age, because I understand this might confuse some of you sometimes it confuses me as well. So with later Iron Age, I mean this. We are in between 300 BC and 300 CE, also known as Samad, Pir, late pre-Islamic, whatever you want to name it. Now, when we think about this chronological period, we picture sites like Samad Ashan in Oman and Dur and Meleha in the Emirates. They're all beautifully well-documented sites, we all know that. But here's the point, and I believe that many of you also from the Bronze Age scholars could relate to it. Most of the later Iron Age sites are mainly located along upper Wadi streams, the alluvial fans immediately surrounding of the Hajar Mountains, and the coastal strips. So the question is this really representative site distribution for the later Iron Age life, or are we missing something? In order to test this question, I chose this as my study area. We are in the Jebel Madar area. The Jebel Madar is that guy over there, you see the mountain, south of the town of the modern town of Sinau, in what we might call a marginal landscape, and I'm using air quotes here. It's marginal because it's drier, there are fewer resources at least known, and there is the laser, it works, it doesn't work, see, okay, but I mean it's useless. So, and the wadi capacities here in the study area is much lower compared to the areas in the northern area where you see Samad Ashan and Mahaliya, for example, where the Wadi Samad and the Wadi Andam are flowing strongly there. So how do you find subtle chronologically specific sites in a place like this? Where should we start? Of course, as you know, remote sensing is a great tool in Arabian context. It's super useful, it's very, very good. But the later Iron Age sites can be elusive. We are talking about subterranean tombs. We are talking about very simple row architectures. We are talking about settlements, sometimes missing fortifications walls, so that they're very difficult to find by remote sensing only. And then there's the reality check, as maybe you might have understood. This is a PhD project, so I have to deal with both time and budget constraints. And this is where archaeological predictive modeling comes in. It's, I mean, for those who maybe are not familiar with it, it's a method which is coming from cultural resource management, you know, when surveyors need to cover massive areas in a very limited time and budget, as in my case. So I've been using both of them as my methodology, and so remote sensing to screen for potential candidates and check archaeological predictive modeling in order to have high and low probability maps, in order to have targeted surveys, and of course ground truthing, because both methods for me are quite useless if we don't ground check what we see from the computer. So ground truthing is super critical. Many predictive modeling studies are usually overlooking ground truthing. They're only relying on statistical tools, but I mean ground truthing is always there. It's the reality we should know first. So today I want to talk to you about specifically about the archaeological predictive modeling part, how I built it, what challenges emerged along the path, and how we can improve it to better understand past settlement decision. So there is no recipe for APM. There are many recipes out there, all right? And, but of course, there are some non-negotiables, like having clear research questions and doing an honest assessment of the data sets, all right, of the available data sets. So after considering this, plus other non-negotiables that are out there in the literature, I came out with the ideas that I needed a method, really, that could fit my research questions. So I need a method able to project predictions from known areas to unknown areas. This means I have a later on age site database. I wanted to take information from these sites, locations and everything, and project them to unexplored areas. Here's the first complication. You see, predictive modeling are full of complications along the path, and we must always deal with that and try to overcome these complications. The first complications is that later on age sites are the database. Sometimes there are sites with a very weak chronological attribution, and there are also sites which coordinates aren't well verified on the field. So I mean, we don't know for sure where they are nowadays. So this means that I had to take out these sites in order to not have like a bias skew modeled in the result, and this means I needed a method able to handle small data sets reliably as well. And since ground truthing is the main core part of this research, I also needed a method that would have allowed me to do iterative refinement after each field season, so in order to improve version after version of the model, survey after survey. After considering the options out there, like random forest, GAM, GLM, whatever method, predictive modeling method, I chose to use maxent. It's short for maximum entropy, which is the principle behind it. And it was developed for species distribution modeling in ecology. You know, when, for example, they wanted to find the habitat suitability, for example, for endangered species. I have my literature folders is full of papers about birds and sloths and everything from this. So it's very funny, by the way. I'm learning a lot. I could actually change the topic of my PhD. And I want to show you how it works with a very simple analogy. Imagine we have 3 identical boxes, and we see this little cutie orange pie in box 1 today. Now we want to know which box will the cat choose tomorrow. Now, many predictive models, strategies, tools will say, oh, the cat is here today, so there are higher chances, high probability that the cat will be in the same box tomorrow as well. But maxent says something different. Maxent makes the least biased prediction, and it spreads the predictions, the suitability. So it says all 3 boxes are equally suitable because they're just boxes, and the cat loves boxes. So tomorrow, this orange tabby cat could be in any of them, all right? As I already anticipated, there are always complications in predictive model. It's never a straight path, right? So modeling is mainly based on environmental predictors calculated from digital elevation models like elevation, slope, waters. I'm just mentioning here the famous ones, but I'm using like tons of them. And for my specific case, I'm using one more source as environmental predictors, namely satellite indices. Because I thought, I mean, these 2 satellite indices, the NDMI, the moisture index, which measures moisture in soil and vegetation, and the NDVI, the vegetation index for vegetation health. I mean, they're taken from modern satellite images, but I noticed that in my study area, the recent landscape alterations are very concentrating and only limited to those very small oases that are there, leaving the great majority of the terrain now. They're almost untouched, at least recently, so I hope that they touched it in the past, actually. So I'm using these. They're usually not so much used in predictive modeling, as well as, I mean, especially the NDMI. But I'm using these, and they are very powerful predictors. Again, complications. This all sounds very deterministic, right? Now, I'm not one of those ugly guys saying, oh, environmental determinism, that's bad. No, I'm not one of that. Of course, it's where all it starts, of course, somehow. But what about people? What about the human decision-making process? How to include it into a model? So the question is, kaboom. What about the human factor? I tackled this in 2 ways. First, by rethinking water variables. And You know, predictive models usually consider distance to waters as very powerful predictive variables, but in my area, and for my chronological period I'm focusing on, later Iron Age, I assume that phallage technology was known. Now, I understand that later Iron Age, there is a very scarce, if absent later Iron Age evidence for phallage technology, but this could rather be for lack of research rather than true absence, all right? But anyway, I didn't exclude the waters, I just considered geological context suitable for constructing phallage, which means subrecent alluvial fans and, of course, alluviums. Now, another point I'm trying to make here with my research is differentiating site functions, because people engage with this landscape differently based on their needs. So I'm developing 3 different models, one for domestic feature sites, one for funerary sites, and one for tomb reuses. I'm not like using predictive model as a bush machine, just put all the sites in and go ahead. So, and these patterns, these 2 human factors are really showing up in the results of the first version of the model. So this is already overcome, but anyway. But just to show you, as you can see in the domestic ones, the one top, you can see that the subrecent alluvial fans are highlighted towards a higher probability, because that means that domestic sites, they relate, of course, with the subrecent alluvial fans. While you see bottom there, for the tomb reuses, the same areas are the opposite. They are not highlighted well. So this means for tomb reuses of Bronze Age tombs, early Iron Age tombs, they didn't care about subrecent alluvial fans because they wanted to use it for domestic, for having oases and so on. But of course, as I already anticipated, we can never trust a computer output blindly. We always get out there and walk the landscape. So we walked 236 kilometers cutting through with transects cutting through the output I get from Maxent. And this is the percentage of distribution of classes we covered actually with my professor and the students as well, they out as well. And here you see that I intentionally chose to work more low probability areas for one single reason. Because before you go hunting for new sites, you want to validate the model. The best way to do that, go checking low probability areas. If they're empty, if you don't find anything, great, the model's validated, all right? But if you do find something in the low probability areas, then it means that the model is heavily skewed and you need to do deep adjustments to it. And what did I find? Well, many analytic tools, especially in the low probability areas. So this already means that in any way, we should never overlook low probability areas, because at least it could give you the wider spectrum of the landscape. Many Afrit and Umanar tombs, early Bronze Age tombs, well, like everywhere, bummer, all right, at least for me, bummer. And early Iron Age, plenty of early Iron Age material. And what about the late Iron Age? Almost completely absent. Now you see, in the low probability areas, great, the model's validated, I didn't find anything. But in the high probability areas, well, this means that the model needs at least a little bit of recalibration. Now, some of you might question if this high probability areas percentage is actually statistically meaningful, but in the meanwhile. So, a couple of things became clear. Sorry, I'm not used to this microphone. I'm used to speak loud. A couple of things became clear. I'm sorry for your ears. A couple of things became clear. The known site distribution is spatially biased. You see all the dots there concentrating in, for example, those are Samadashan and Mahalia sites. So this means that the site database needs further thinning. Some later Iron Age sites are usually, especially the settlements, are usually located on outcrops, hilltops, plateaus, of course, for good visibility and defensive advantages. But in the area, we checked all of them, all these geological features, and we exclusively found Bronze Age and early Iron Age funerary fields. So this could be already another insight for refining the model. So of course, how to refine it? Dataset thinning, as I said, by limiting the spatial imbalanced bias in overrepresented areas, by using true absence points. This means I've genuinely collected, I collected genuine negatives, which means archaeological sites from any chronological period, but later in age, in order to tell the Maxent, hey, this is what true absence look like, because I know from literature, from my previous survey, that this is what it looks like. So don't take any guess, don't go out there checking for random points and everything. So I'm training the model with true absence points. By the way, if any of you would like to share any site coordinates, this is my greater area, going more or less from Sohar to Oteiwei, and from, like, let's say Bat, because down there, passing through Adam and Jalan Bani Buali. So if any of you would like to share site coordinates from this area, I would be glad to stay in touch. And how to further refine the model? By using more human factors, by, for example, reconsidering the vegetation index, not just as the plain output I get from stacking the satellite images band, but, for example, having, I don't know, I'm considering right now the growing distance from the high vegetation signals I get from this. And now I want to show you something very fascinating, at least for me. I don't know if you agree with me. This is the last output for the domestic sites I have after all these refinements, after considering and improving the model. You can see there is one environmental predictor that is ruling them all. Is there any guess from the audience? No? You're all thinking about the next coffee break? Yeah, me too. And it's the vegetation index. It's the distance to the high vegetation signals, all right? And so you can see that the very high probability areas, they're focusing in and around modern oases and modern crops. I've been using, of course, images taken from Landsat 5, so this means 1985, 1986 images in order to kind of limit the super recent landscape alterations, of course. And the question is, can we trust this? You see, there are always complications. You always have to ask more questions when you have a computer output. Can we trust this? Does it mean that later in age communities genuinely favored these places for, of course, availability of groundwater and for availability of arable land? Or, and I guess maybe it's the second one, decades of archaeological research in Oman and in southeastern Arabia have been heavily biased towards modern oases because that's simply where people still live and work, making sites first easier to find there than in other remote regions, where, of course, I know there weren't even paved roads, for example, in this area until like 20 years ago. So in order to test this hypothesis, in order to test this last version of the model, I'm planning a next year's survey strategically to see whether the vegetation index then is a reliable predictor and whether this shows research biases. Now I want to show you really briefly a short post from all these computations. I just want to show the curious among you here very briefly that by ground truthing remote sensing anomalies, I found, you got me. I was actually able to find many triliths as well as later in age tomb reuses in Bronze Age tombs. So this means that the area was alive during the later age period. It was not ignored at all, but to what extent? This is still an open question, and I hope to see you at next seminar. I hope to participate, actually, at the next seminar and show my final results about this and my, perhaps, answer to this question. So what's the bigger picture so far? I have no solid conclusions. Of course, it's still an ongoing PhD project, so what's the bigger picture so far? First of all, projecting settlement patterns from one region onto another requires careful validation. What works somewhere, what drove the decision-making process somewhere may not work somewhere else, all right? So we must always carefully validate this. And secondly, the spatial and temporal variables in predictive modeling are not black boxes. We cannot just plug in data and trust the computer output blindly. We must assess whether this reflects true ancient behaviors or modern research bias. That's why, for me, at least, field validation is not an option in predictive modeling. It's something that transforms a statistical exercise into archaeological interpretation. Let me thank, finally, something and somebody, the institutions, University of Würzburg, where I'm doing my PhD, the Altorientalisticum for the Asiatische Archäologie department there, the Gerda Henkel Stiftung for financial support, and the Ministry of Heritage and Tourism of Oman. Many people have been contributing to this work. I should have had maybe some names from the recent days, but I would like to particularly thank Steffi Doper, the chairwoman, my supervisor from Würzburg University, Philip Verhagen from VU Amsterdam, key advisor for the modeling part, and I would like to particularly thank here today Derek Kennett for sharing unpublished data from the Rostock Batin archaeological survey, very helpful to train the model. You can find here all of my contacts. If you have questions, if you want to know details, if you want to share anything, like, I don't know, also tomorrow, while drinking a Faluda and enjoying a view at the Corniche from your fancy hotels or from your plane, and you think, oh, I should have asked that guy yesterday about this, about that, please, please, please do write me, email, LinkedIn, Instagram, pigeons, letter, whatever. Thank you very much. Thank you for your attention.
Thank you very much, Fausto, and thanks for the invitation for drinks, if that's how I understood it. Are there any questions from the audience? We have enough time for questions. Yes, please, Pia.
Not about lithic, Pia. Wait for the mic. I'm getting old here.
I'm also used to shout in empty rooms. Did you find a pattern like to the less probability area? Did they correspond to a higher percentage of Neolithic sites, for example, medium to Bronze Age tombs, or the other way around? Like, how is the ground truthing result compared to the from high to low probability results from your model at the moment?
So you're asking, chronologically speaking, especially for the lithics, where did I find, in which classes I found all these things, right? So for the lithic tools, I found many of them in the low probability areas. And, well, that was not expected, honestly, because they were actually found mainly on these wadi terraces, you know, or yes, very low terraces around these very shallow wadis that are there. And I didn't expect that because, I mean, those were, at least in the first model iteration, they were like high hotspots also for later age. So I was quite surprised, honestly. I expected to find more pottery, but I found lithic. For the earlier Bronze Age tombs, I mean, they share more or less the same pattern of lithic tools. I found also lithic tools really next to early Bronze Age tombs. So they were more or less from the same area. In the medium and higher, yes, the early Iron Age funerary fields, they were a bit tending to the higher. And for the triliths, they were all in the low probability areas, but that's good because we all know that they are far from settlements. So that's fine because, I mean, from the domestic models, for example, I found triliths in the low probability areas, so that's how it resonates somehow, no? And for the tomb reuses, it doesn't work quite well, the model so far. Right, so I found many tomb reuses in lower probability areas in 1, 2, 3, so until the medium one, and like just one in the higher probability areas. So there are still some work to do, actually.
Okay, thank you.
Any other questions? Anything you want to know? Yes, please, Pleda.
Thank you, Fausto, for a very interesting lecture. So my question is really, so you have all these features and sites that you're detecting and ground truthing, but the real issue is how to date them, which is often very difficult on the surface if you find stuff. But many of these places you don't find anything. Yep. So how can you control for the chronological part?
Yeah, of course. I've been trying to date what it's kind of certain to date. I have many points with uncertain attribution. I'm not taking anything for granted, right? So if, honestly, I don't know what it could be, what it for sure or nothing, I'm going for uncertain attribution because I'm not going to push or over-push attribution, chronological attribution, because I know that already, especially for the later age, there are many biases also in this meaning. I don't know, for example, the early Bronze Age tombs, they are, for the findings, I didn't find any early Iron Age material next to the early Bronze Age tombs, cairns and beehive. So I'm dating mostly for architecture and for what I found, like pottery, some also Jemlet Nazr vessel and everything. For the early Iron Age, I mean, the pottery and the soft stone vessels, I found some sherds, of course, not vessels. For the early Iron Age, they're quite super diagnostic. For the later Iron Age, I'm actually following like iron tools, iron arrowheads, because they're almost completely missing the early Iron Age. So I'm taking that as a super diagnostic element, and a soft stone spindle whorl, super polished with circles around, which is very typical also of the late pre-Islamic, late Iron Age period. It's fair enough. All right, thank you.
Thank you.
Thank you very much. I can't see any other questions, so thank you very much again for your presentation. And I want to invite the next speaker. This is Chloe Girardi, and she's talking about worship in the shadows.
First of all, I would like to thank the organizer for giving me the opportunity to share, some of our results with you. I would also like to thank my co-authors, since the results I'm presenting today are, above all, the product of collective work. The title, Worship in the Shadows, may sound a bit mysterious, but it reflects the remarkable setting of a small funerary shrine I'm about to present, nestled at the foot of Dadan's cliff that you can see here, and overlooking the ancient settlement. Dadan is located in the northwest of Saudi Arabia, in the oasis of Alula. Since 2019, the Saudi-French Dadan archaeological project, co-directed by Jérôme Romer and Abdul Rahman al-Suhaibani, has been uncovering this caravan city at the crossroads of major trade routes across the peninsula. During the second half of the first millennium BC, Dadan was the capital of the kingdom of Lihyan until the Nabateans arrived. The small shrine discovered in Area D, with the yellow star on the right plan, dates back to the Lihyanite period and offers a glimpse into the city's religious life. Although the shrine remained buried for over 2 millennia, its inscriptions have been known for more than a century. In 1884, Euting produced an estampage, later used by Müller for the first translations. Jossen and Savignac later published a new translation of the panel of 6 inscriptions, known as J.S. Lih 72 to 77, with a photograph also that they published to the left, taken shortly before part of the panel was destroyed. And to the right, you have the same picture, but at the current moment. These inscriptions puzzled Jossen and Savignac because they mention a tomb, some statues, and a funerary monument, but yet none of these elements were visible in the area. In 2017, a team from King Saud University opened 2 test pits below the niches and discovered a few object fragments, but closed the area very soon. In 2020, the Dadan Archaeological Project identified the remains of a shrine excavated over 4 seasons. Excavation began with a trench at the foot of the cliff, below the inscription and the 2 niches. The discovery of numerous scattered object fragments that you can see inside the trench prompt us to expand the excavation. This revealed a small north-south wall and clarified a little bit the extent of the demolition layer, which was full of hundreds of fragments. To record stratigraphic sections, since 2021 we used an opposing quadrant excavation strategy, explaining the steps visible in some field pictures. In 2022, we finally closed Area D, which is the last pictures, after partly exposing the bottom of the abandoned quarry in which the shrine was built. Stratigraphic data will now be presented chronologically from bottom to top. The earliest activity in the area relates to sandstone extraction. Excavation exposed the bottom of a stepped quarry, but for safety reasons, we could not fully clear the westernmost step. Clear tool marks were visible everywhere on the quarry floor and walls. Lacking archaeological material, the quarry cannot be precisely dated, but a charcoal from a hearth found within the quarry's abandonment field yielded a date between the 8th and 4th century BC, indicating that quarrying had ceased before 400 BC. After abandonment, the quarry was filled with rubble from other quarries. Once more than 2 meters of rubble had filled the quarry, the area was reused to install at least 2 graves. The first one lay in the northeastern corner of the quarry beneath the small niche. You can see it in the picture. This niche may be contemporary with the burial or maybe slightly later. The grave was a simple pit dug into the rubble. It contained the remains of an adult of undetermined sex, placed on the right side in a flexed position, the head to the north and the end toward the knees. Half of the skeleton was destroyed by a statue-based installation during the following phase. That's why you see in the skeleton that a lot of bones are missing. The second grave was entirely destroyed and only a mandible of a child aged about 4 to 6 years old was found thrown in a later pit. Next to grave 123, a small hearth seen here in the circle with remains of burned date fruits and caprine bones suggests that food was consumed during funerary rites or maybe offered. Both burial 123 and hearth are dated between the mid-4th and the 2nd century BC. Without any clear stratigraphic or chronological break from the funerary phase, the next stage in the sequence is marked by the gradual introduction of numerous stone cultic objects. This is why we refer at this period as the early shrine phase. The two niches shown in the central picture, as well as some of the inscription, may belong to this early phase, or perhaps even to the preceding one. The installation of cultic furniture led to the accidental destruction of half of grade 123 that I already mentioned, and the stone objects arranged along the northern and eastern walls of the quarry include many types of objects like altars, statue bases, basins, betils, and toward the end of the phase, offering tables with spouts for libation. But what really characterized this phase is the presence of extensive ashy deposits, shown in gray on the top plan, made up largely of charred food remains, such as pieces of bread or maybe cakes. Unfortunately, no hearth were found in situ. Instead, this layer of ashes represent the cleaning of altars and were the only material available for dating, but still not in situ. Radiocarbon dates from this layer overlap with those of the following phase, but taken together, they suggest that this early shrine should be placed around the 2nd century BC. A betil was identified within the assemblage of cultic objects set against the eastern wall, because if this block was unworked, this standing stone was firmly set into a small pit with wedging stones to hold it upright. The phase 4 data allow us to propose this reconstruction of the early shrine. In it, you can see the cultic object, ashy deposit, and two statues placed against the eastern wall. The late shrine corresponds to the reorganization of the cultic space. The area was enclosed by a north-south wall, aligned with two pillar bases visible in the drawn picture and on the plan. This rather simple arrangement likely supported a shelter, which may explain the notches on either side of the main niche and probably used to hold the beams. Inside this enclosed space, the floor was coated several times with a yellow earthen floor visible in this picture. New cultic objects were added along the northern and eastern faces, partly covering earlier ones. Although radiocarbon dates for phase 4 and 3 overlap, the later shrine can be placed between the 2nd and the mid-1st century BC. The in situ objects combined with the analysis of the distribution of fragments allow us to propose this reconstruction of the shrine, but without the shelter, and as you can see, densely filled with cultic artifacts. The shrine story ends with violent destruction. Most objects were broken and scattered throughout the demolition layers. You can see hundreds of pieces in the top picture and plan, creating a jigsaw puzzle that kept our stone restorer busy for 6 seasons. Many statues show pick marks on heads or torso, as you can see in the picture, as if they had been deliberately killed. Fragments lying directly on the last floor show no abandonment between use of the shrine and this destruction. The absence of looting suggests ideological rather than economic motives. And given the regional context, it is tempting to link this violent episode to the arrival of the Nabateans in the oasis during the second half of the 1st century BC. Now that we have covered the stratigraphy, I will briefly present the artifact and what they reveal about the shrine's use. First, the ceramic assemblage is small but remarkably coherent for the Lyrianid period. Compared to other areas at Dadan, open forms such as bowls or beakers are proportionally higher than closed forms like jars and pithos. This pattern may reflect the cultic function of the site. The faunal assemblage is also small. It is dominated by mammals, mainly caprines, but there are also camel, equid, dog, red fox, and rodent. Few bird, fish, and seashell remains have also been found. But the presence of fish and seashell is striking, given the distance to the Red Sea. We found parrotfish, giant clams, panther scories, and small cories, but the small cories may have been worn or accidentally lost. The seed and charcoal assemblage is also small and shows lower diversity than elsewhere at Dadan. What stands out is the large amount of charred fragments interpreted as prepared food, like maybe bread, cakes, or the like. The exclusive presence of dates among fruits is also interesting. Among the cereal, we only find seeds, no post-harvest byproducts. Also, wild taxa are rare in Area D. This points to a non-domestic occupation and a regular cleaning of the space. People likely brought ready-to-eat food into the shrine, such as bread, cakes, and dates, either to consume or to offer. Focusing on stone artifacts, I won't present every single object, but I want to give you an overview of the quantity and quality and diversity of the assemblage. First, at least 28 statues were identified, from 20 centimeters to 1.60 meters for the tallest. Seven statue bases were also discovered. All the statues depict men wearing loincloth, belt, sandals, armlet, and either long hair or headcloth, sometimes held in place by a headband. At least one statue was seated, the third one, and two had preserved inlaid eyes. 22 oblong blocks may be betils, but only one was found in situ. I already speak a bit about it. Tests suggest that one of the betil may have stand in the small niche. Other fitting tests with offering tables show that their back notches were more suited to hold standing stone than statues. Among the paraphernalia, at least 18 quadrangular offering tables were found. Each has a rear notch, possibly to hold a betil, a small square recess in front of it, and a larger recessed area with 1 or 2 spouts for liquids. Chemical analysis of residues produced very interesting results. They included conifer and fir resin, non-ruminant animal fat, vegetable oil, and dairy products, such as possibly goat milk. This finding give insight into the substances that were used in the cultic practices in this shrine. 16 incense, or rather perfume burners, have also been discovered, ranging from 5 to 45 centimeters in height, and mostly quadrupod. Chemical analysis of residues produced similar results, but at least one bore traces of frankincense, in the form of a burned branch rather than pure resin. Among the paraphernalia, we also include what we have identified as altars. The ones visible here are circular or cylindrical, but some large unworked blocks were also used as offering supports. At least 23 altars have been recorded. They are considered as hybrid objects, combining features from incense burners, offering tables, or even maybe of betils. Finally, at least 6 stone basins, circular, oval, or quadrangular, demonstrate the role of collecting liquids in the liturgy of this shrine. I won't go into the detail of the inscription in the shrine today, so as that could be the subject of another talk, but 6 inscribed objects have been discovered. 3 of them are statue bases, 2 of them are dedicated to Abalaf, and the third one to Salman. A kind of stela or betil, a large incense burner, and a statuette. But the most striking is the curse inscribed on a block, so it's the second one on the lower row, which was found near the fallen largest statue. According to Falkland Kostra reading, it says, "May Abelaf crush and destroy the posterity of the one who removes the two statues from their place." Unfortunately, we received the translation the day after the removal of the statue by the whole Dadan team. The inscription on the cliff could also deserve a full paper, so I won't go into the details. I just wanted to show that archaeology allows us to place some of them within our phasing. For example, we suggest that inscription 72, the highest one in yellow, and inscription 77, the lowest in blue, were among the earliest to be carved. They may have been inscribed during the early shrine phase, or perhaps even during the funerary phase. Later, when the shrine was reorganized, inscription 72 would have been hidden by the roof, because you can see the small notches on either side of this inscription. As for inscription 77, during the reorganization of the shrine, it ended up hidden behind the largest statue. Indeed, when we place the statue back in its original position, it hides the northern half of the text. Moreover, at least two other inscriptions, 74 and 75 in purple, seem to have been carved around this statue. They name artisans who created these statues, so maybe this one, including two statues which are named to be representing a certain Abalaf. So now, combining stratigraphy, artifacts, and inscription, we can start to think about the role of this shrine within the Dadanite community, though the data raise more questions than answers. What follows are hypotheses rather than conclusions, and we are eager to hear your ideas. The assemblage of statues and cultic objects shows the cultic nature of this space and allows us to consider it at a shrine. The objects look very similar to those from Dadan's main temple at Zuhabat and to the high place sanctuary of Daraj. Yet, the statues in Areade are much smaller than the colossal statue from the main temple, and the number of cultic artifacts is far lower than at Daraj. The architecture also differs sharply from these major cultic places. In the shadow of the cliff, here everything is on a small scale. This was not a major pilgrimage site or institutional temple. The built elements seem like improvised, likely added gradually as more objects were deposited. The layout is minimal, pointing a small, modestly constructed shrine that developed over time. Finally, among the three cultic places compared, only Areade bears funerary inscription. For this reason, we tentatively consider it as a funerary shrine, likely used by a family or clan to honor their deceased and ancestor. But if it was a funerary shrine, where are the burials? The phase 5 burials beneath the shrine may have been directly connected to it, or they may have been earlier, unrelated graves around which the shrine has later developed. In either case, inscription and offering appear to have been the main commemorative practices. The inscription suggests that the area was appropriated at some point and possibly consecrated by two prominent figures from Dadan, the two Kabirs of the party of Hanas, which are called Abalaf and Haram Nahar, which are named here in the 72 inscription as a historic personage. Dadanitic statues are usually understood to represent dedicants. However, in this case, the inscription refers to Abalaf and Salman as supernatural entities to whom statues were offered to obtain protection. Thus, the historical figure of Abalaf may have been deified as a clan ancestor, which would make some of the statues from Areade one of the rare examples of divine anthropomorphic representation in Northwest Arabia. At the same time, the Betils likely represent deity or perhaps the deceased themselves and served as focal point for offering and libation. This indicates that the cult of standing stones was also an integral element of Lihyanite religious practices. And if I still have about 3 minutes, I would like to take you through a short film that retraces the entire development of Area D, from the first quarrying activity that you can see now, all the way to the final abandonment of the site. Once the quarry was abandoned and filled with rubble, this space was reused for burial. At least one individual was interred here, an adult crouched on its right side, the head to the north and the hand toward the knees. Next to him, a hearth has been used to burn some date palm fruits and meat. This burial was later cut by the establishment of the first shrine. Niches and some inscription may have been carved during this phase. Even at this early stage, the shrine already had a remarkable diversity of cultic objects. And you can see here the lowest inscription, 77, which could be related to this early phase of the shrine. As the video continues, you now see how these early objects were gradually buried by later artifacts. More and more items were brought in layer after layer. The space was also reorganized and given a slightly more monumental character. A north-south wall was added, the floor was coated with yellow earth, and 2 pillar bases were installed to support a lightweight shelter, of which we propose a reconstruction. So here you have an idea of the interior of the shrine with the shelter. You can see the seated statue and also the tallest one, which is hiding the lowest inscription. And there is a small lamp which has been reconstituted from a shard of Attic ceramics, which have been identified as a lamp from Shadi Shabo. The shrine was then violently destroyed, so you can have an idea of all the statues broken and on the floor. And then the area was abandoned. And this is almost the way where you can see it right now in Dadan archaeological site. So if you want to see this video another time, it has just been installed in the new visitor center of Dadan. And I thank you all for your attention.
Thank you very much for this impressive overview of the shrine and its reconstructions. Are there any questions? We have time for 2, maybe 3 questions. Yes, please.
Thank you very much. I wonder if these statues have any inscriptions on them.
Just one. There is a small statuette with an inscription and it's just a name. The other one are not inscribed, but 2 of them are put in some statue base with inscription. 2 statue bases are inscribed.
Thank you.
Any other questions? No. If not, then thank you very much again for your presentation. And we move on to our next speaker, which is Guillaume Ganet, and he will talk about Iron Age settlement, necropolis, and infant funerary complex at Manaki.
Thank you, Stephanie, and good morning, everybody. Well, the identification of the large complex at Manaki during a survey conducted by Derek Kennett and Nasrat Jahwari in Batina Governorates about 10 years ago prompted in January 2024 the beginning of excavations conducted by a joint Omani and French expedition co-directed by Mohamed Hussein with the help of Sultan Qaboos University professors Nasser Al-Jahwari and Khaled Douglas. The ongoing research program aims to clarify the spatial and architectural organization at the Manaki settlement. It also seeks to investigate trade circulation within Manaki's highland-lowland corridor. Part of the research has been dedicated to funerary customs and chronocultural features of the late Iron Age and pre-Islamic period. For these reasons, research at Manaki falls within broader topics of interest related to the early Iron Age and the late Iron Age, which are illustrated on the slide and do not require further comment for now. This presentation is structured in 3 parts. We will begin with the early Iron Age village and briefly present the late Iron Age tombs and finally conclude with the funerary complex devoted to infant burials. As mentioned earlier, Manaki is located in the Sus al-Batina governorate, that is, in an intermediate region between the coastal plain and the peninsula and central of Oman. So let's start with the presentation of the first results obtained about the early Iron Age settlement, which are very, very preliminary. The early Iron Age is characterized by the wide variety of sites, including cemeteries, settlements, forts, cultic sites, and afflage irrigation systems. Most known early Iron Age settlements have been excavated in the northern part of the region, such as Rumaila, Muela, Masafi, Hili, and Tel Abrak. Whereas only a limited number of villages in Oman have been investigated, including Salut and Manal, for instance. Manaki is located on the western terrace of a large wadi flowing from the mountains south of Rostak at the foothill of the Hajar Mountains, at an intersection of 2 routes, one following the wadi and the other running along the foothills. Manaki is only one of several Iron Age sites identified on both banks of Wadi Rasab, locally known as Wadi Farah. This suggests that the site formed part of a broader complex with an important economic and political role, controlling routes from the mountain to the coastline and along the northern foothill of Jebel Hajar. The site itself was divided into 4 areas, and the excavation started in Area 1, which is the central area with the highest density of structures. Up to now, 5 buildings have been cleaned and sounded or at least partly excavated in Area 1. Those 5. As you can see, it's very close to the wadi. Although erosion had affected the upper crosses, the surviving stone foundation of building 11, covering roughly 45 meters square, enabled a partial reconstruction of the plan. The remaining architecture consists of at least 2 adjacent rectangular rooms, separated by a narrow stone wall and enclosed by thicker external walls, built from 2 parallel rows of unhewn and semi-hewn stones. Material found from building 11 consists of early Iron Age domestic pottery sherds and 3 terracotta figurines, including 2 anthropomorphic examples, which is exceptionally rare in Oman. Despite erosion and collapsed debris, the initial clearing of building 19 revealed a distinctive linear structure composed of a row of at least 5 east-west aligned rooms bordered by substantial outer walls. The visible walls consist of a double-faced masonry built from unshaped and semi-shaped stones with a rubble core. Once again, early Iron Age pottery was identified, Notably, building 19 yielded 11 figurines, one depicting a kneeling human figure. You see in the upper right picture. Building 20 is located on the plateau of Area 1. Surface cleaning and a rectangular trench revealed a rectilinear structure oriented northeast-southwest and measuring about 14 to 4 meters, and composed of at least 4 adjoining rooms arranged in a linear sequence. Despite erosion and the shallow stratigraphy, several installations such as fireplaces, pebble-paved floors, and stone platform were identified. Building 20 produced the largest pottery assemblage documented so far in Area 1 at Manaki, with about 800 sherds, predominantly dating to the Iron Age II period. The pottery parallels well-known forms from Salut, Lisk, Rumeila, and Mudmar, including sinuous incest jars, thick-lipped bowls, and basins with raised lugs. Remarkably, Building 20 yielded an exceptionally dense concentration of terracotta figurines. 18, far surpassing quantities known from most Omani Iron Age sites, as well as several decorated elongated handles with serpent-like motif and short oblique lines. These artifacts closely parallel incense or perfume burners known from cultic building at Bitna, Rumeila, Salut, and Masafi. Taken together, the unusually high number of figurines combined with snake-shaped and decorated implements strongly suggest that Building 20 may have served a ritual or symbolic function within the settlement. Building 1 is the larger of the site, over 300 meters square. Only the original surface layout was excavated, making it possible to delineate several rectangular rooms, corridors, and doors. It's also the best preserved building in elevation, suggesting the presence of a substantial stratigraphy. Among early Iron Age pottery, a sediment print on jar was discovered, depicting a winged anthropomorphic figure holding an unidentified animal, possibly reptiles or turtles, in each hand. Sealed jars are very rare in Oman, and there are only a few examples in the Emirates, so it will be interesting to discuss with a specialist of glyptics. The first investigation about the early Iron Age at Manaki show buildings with unusual shapes, difficult to analyze due to severe erosion, except for Building 1, which remains to be explored. There are numerous questions regarding the unusual presence of figurines, both quantitatively and qualitatively. Moving to the late Iron Age, or somewhat late Iron Age period, most data concern tombs. A lot of funerary monuments were built over the ruins of earlier buildings. 7 of them were excavated above Building 1, located side by side. They consist of long oval chambers surrounded by 1 to 3 concentric rows of large pebbles, with walls no higher than 2 courses. Most of the graves have been looted, with the exception of Tomb 6 to the right. This one, Tomb 6, whose very poorly preserved skeleton belonged to a child, and it held various silver ornaments, including bracelets, rings, and beads. Bracelets and anklets are here. Similar tombs are present across the entire site, especially above the largest early Iron Age buildings. Their visibility leads to almost systematic looting. But based on their shape and grouping, they appear to be both adult and child tombs, perhaps belonging to the same families. No associated habitations have been identified near the necropolis, raising questions about the type of settlements and the way of life. But the more enigmatic excavated monument up to now is the building number 2, including both architectural remains and burials. Judging by the intentional filling of the rooms made of pebbles and the absence of doors, it would appear that the remains found were all at foundation level. As a result, we are unable to identify the original function of the spaces, if any. Even though we can see an axial corridor bordered by two sequences of two rectangular rooms in the southern half of the building, and a large, almost square and later hall forming the northern half. This is bordered to the west by a small rectangular room added in a later phase. The construction date of this building is uncertain. It should be early Iron Age according to the other buildings in Area 1 and construction techniques, but its funerary use seems mostly late Iron Age. We'll start with the tomb T109. In the center of room 1 lies the large looted tomb 109, dug into the pebbles layers and lined by large stone blocks, which contain the remains of 6 adults and 1 subadult. The lower layer, with the exception of tibia and the left foot of 1 individual, all the bones were found mixed and often fragmented, mixed with sediment, a few stones and material clearly dated to the late Iron Age, including jars and a local type of so-called pilgrim flask, with a good parallel from Yancourt, and there is also one in this museum. I just discovered it yesterday. There are also, these are the pottery, the complete pottery that have not been destroyed during the looting. This is one parallel from Yancourt. And there are also iron fragments, faience beads, and other ornaments in this tomb. But the most unexpected discovery revealed by the excavation of Building 2 is the very specific funerary function of the building. 54 graves and 5 groups of scattered bones were located, and all being children, infants, neonates, and fetuses burials. At least some of the tombs post-date the destruction of the building because they damaged certain walls. But some could be contemporary with it. So far, the only known function of this building is finally funerary. There are 3 types of tombs devoted to infants, neonates, and perinatal. Type 1 are stone-lined pits with a rectangular shape, regular shape that could be rectangular, oval, or semi-oval shape, locating along a wall inside or outside the building. Graves of type 2 are stone-lined pits with irregular shape, reusing the collapsed stone or moving wall stones. And graves of type 3 are simple pits. The walls of type 1 graves are made of vertical pebbles and stone of different sizes. Among examples of type 1 is tomb 37 of a child between 4.1 and 9.8 years old. It was found in a crouching position on the right side, face to the waist. Between his feet and the wall is a spouted pot with a basket handle. A child of the same age, buried with a globular cooking pot and a necklace, is buried in tomb 88 of type 2. They are the older buried children of the site. Most of the other tombs of type 1 and 2 belong to infants that passed away between their 6 months and 1 year old. This is the case for tomb 4. The very damaged skeleton seems to lay on his back, carrying a spotted pot with basket handle once again. One can also mention T153, damaged by a stone that collapsed into the funerary room. Also, other tombs were found with an individual of the same age, and one is even younger. This is 143. and the younger is 6 months, 7 months is in utero. The last type is burying. We observed that some of this one, even if this fetus is buried in a tomb of type 1, most of the youngest are neonates and fetuses come from type 3 tombs, simple pits. Sometimes perceptible in the filling sediment, as you can see here. Well, funerary goods are rare. Most infants were buried without any object. In other cases, they consist of a necklace of a few beads made of from various materials and one pot, maximum one pot. Either a cooking or a grey ceramic jar or a spouted pot with basket handle. The initially recalled forms known in Iran during the early Iron Age, but the radiocarbon dates obtained from the bones indicate the late Iron Age period. Additional C14 datings on the bones will help to refine the chronological framework of the tombs and the whole funerary complex. No strict correlation has been observed between the location of the tombs, the tomb type, the age of the individual, and the presence or absence of grave goods. However, certain trends can be noted. Tombs whose one side is formed by the wall of the building tend to contain more pottery material and beads than the others. And simple pits are often associated with the youngest skeletons. The sum of data, building to include 54 or 55 perinatal infants and children with maximum 6 to 9 years old. But its original function is still unknown. Is it a funerary complex from the outset? Even if the chronology of tombs still need to be determined precisely, the building indicates a long-term use. It is a unique case of a funerary complex dedicated to children in southeastern Arabia for this period. And how can it be explained? Of course, we will investigate more. So much remains to be explained, and further study of the tombs, their chronology, the stratigraphy, will shed more light on this funerary building. To conclude, after 2 seasons of excavation, data obtained yielded more questions than answers. Most tangible elements are the early Iron Age village that could be one of the largest in Oman. The late Iron Age graveyard above it, revealing ruins to set up isolated tombs or group tombs, and this funerary complex, mostly devoted to infants, but it is still uncertain if the function started during the early Iron Age or the late Iron Age, and which remain very enigmatic, waiting for a complete excavation and study of its content. And I would like to thank you again for your attention.
Thank you for your presentation. There's time for questions. Any questions from the audience? No, there's a microphone coming from the back.
Thank you. Thank you very much for the really interesting presentation. I just have a question about the early Iron Age settlement. So the end of it, do you have any traces of burning or, complete collapse?
We have really few data about the end of this settlement because the erosion is so strong that there is almost no evidence of any destruction layer. But even the occupation layer are very thin, and when I say very thin, it's a question of centimeters. So we miss data, except apart from one of the building, which just started to be excavated, the middle one, with a stratigraphy. And in this case, we observed that some of the pots are destroyed in situ. So maybe in this case, we will have enough data to know if the end of the early Iron Age is like problematic, like a fire, a destruction or something. But up to now, it's only preliminary, so I have no clear answer for you.
Okay. Thank you.
Welcome.
was not just me. Hi, Guillaume. Thank you very much. Very interesting presentation. I know that it's impossible to say, but have you noticed any particular pattern that could help trying to suggest the gender of the neonates and infants from the burial and the grave goods? Of course, not from anthropological way.
No, for the gender, it's not possible according to the age. And to be honest, the study is still ongoing. So the anthropologists are working, and only a part of the bone have been studied to identify at least the age, which was the main purpose. But of course, there should be other analyses. There are some indication about pathologies and so on. But still, we are a bit surprised because usually it's not rare, but it's not common to find for this period infant burials. There are some in Mleiha, for instance, that have been published, but it's a question of 2 or 3, not much. So the first thing is to complete the study of the anthropology studies, and to also precise the archaeothanatology study, because there are a lot of indication according to the funerary customs, but we are at a very preliminary stage. So yeah, we will continue this, and I hope we will have more indication about this.
Any other questions? We still have time. We're surprisingly ahead of schedule. If not, then thank you again.
Welcome.
And I would suggest that we wait a little before we start the next presentation in case people from the other sessions want to join, because as I said, we're ahead of schedule, so you can sleep for 5 minutes and then you please pay attention to our next speaker then. Okay, everyone, we're going to continue with this session, and I'm happy to introduce the next speaker, which will be Sepp Lena, and he's going to talk about fueling Iron Age ritual economy in the Rub al Khali.
All right. Well, good morning, everyone. Thank you very much, Steffi. Thank you, Peter, earlier, knowing that he had to run. Let me see if I can get this working. There we go. Okay, so I'd like to thank the conference organizers, speakers, and attendees, of course, in this year's seminar, and what's truly been an illuminating advance in our field. This particular seminar here in Abu Dhabi is an extraordinary event, and I'm really pleased and happy and honored to be a part. So this morning, I would like to present our work today from the 2024 and 2025 field seasons at Saruq al-Hadid, which really focused on Site 53. Some of you may already be familiar with Site 53 as it was presented during the last seminar. But this work really would not have been possible without the generous support of the Dubai Culture and Arts Authority, and in particular, the director of the Antiquities Department, Badr Al-Ali, Dr. Mansour Baraik, and Mariam Al-Suwaidi, all of whom I am deeply indebted and appreciative for your collaboration. I would also like to thank my collaborators at Chronicle Heritage, whose expertise and logistical support in this project has helped really drive a lot of what we do. And I'm indebted, of course, to the co-authors on this paper and the many others who helped drive the fieldwork and post-excavation analysis, a part of which I'll be presenting on today. So Saruq al-Hadid, as many of you know, is located on the margins of the Rub al-Khali Desert along the southern boundary here of Dubai in the United Arab Emirates. Previous investigations at the site by multiple local and international teams have identified the location really as an area of persistent short-term occupation, extending really from the Neolithic through into the recent past, with a particular density of activity in the Bronze and Iron Ages. Now, the exact boundaries of the site remain elusive, yet we can confidently say from superficial remains identified through survey and targeted excavations, and in particular at Saruq 7 and now in Saruq 53 to the east, that material culture related to the Saruq al-Hadid phenomenon extends at least 1 kilometer square and is likely much more than this. Now, one of the most important aspects of Saruq al-Hadid is contained within the early Iron Age, when a confluence of industrial activities, including several independent lines of evidence for metal craft production and recycling, shown here, of course, are the extensive distribution of copper slags, together with ritualized deposition of status objects and materials, and objects often with elaborate symbolism. Now, in general terms, this constellation of activities is part of a deeper time pattern of community building in the area, and that extended into the Bronze Age, of course, too, evinced in particular by wild foods consumption and exploitation, and commensality in a lot of ways. With evidence predominantly derived from excavations in the so-called central sector of Saruq 7, and extending over a period of the Bronze and Iron Ages, Lloyd Weeks and many other folks proposed that the site was the locus of activities that form the basis of interaction between multiple communities with the effect of essentially social integration and shared identity. Yet for those familiar with Saruq al-Hadid, this incredible evidence for this intense activity is coupled with a difficulty to explain this phenomenon in light of our greater understanding of the Bronze and Iron Ages in regional southeastern Arabia more broadly. And all of these activities took place on the fringes of an increasingly arid and dunal environment with marginal access to water and far away from traditionally understood settlements and pastoral watersheds. Now, functional hypotheses that have been posed to explain this phenomenon, this anomalous site in some ways, stress the importance of trade and exchange, industry and production, and ritual and ceremony, and all of which underscore the importance of social gathering, really as a real driving process happening deep out here. Now, previous work at Saruq al-Hadid in particular in this so-called central quarter and the northeastern quarter, Saruq 7, has developed a good understanding of both cultural periodization and absolute chronology, with scores of radiocarbon dates represented in both of those regions. Investigations by Lloyd Weeks and his team's fundamentally important synthesis of these data describe the periodization as a series of horizons. While work by El Khalid later on, published last year, has provided extensive evidence for earlier 4th millennium dates from pits cut into the basal gypcrete below the sand dunes. In general, the 5 horizons can be grouped into 2 or so groups, demonstrated by the synthesis of radiocarbon dates shown here as kernel density estimates. Horizons 5 and 4 are defined by Bronze Age deposits and material culture with extensive evidence for wild animal exploitation and commensality. And horizons 3 through 1C include a majority of early Iron Age dates with some evidence for later ephemeral activities up to the present, represented by horizons 1B and 1C. Now, the early Iron Age deposits are incredibly complex, demonstrating a combined and somewhat chronologically and spatially defined focus of craft production, in particular both primary and secondary metal production activities and recycling. The intentional deposition of elaborate status materials, ranging both from locally produced materials and those originating through long-distance exchange, essentially forming ties, trade ties for very, very distant regions. Now, one of the big questions regarding these activities is how communities procured and utilized energy sources to actuate and mobilize these activities. Now, the fuel source behind the ritual economy of Saruq al-Hadid remains elusive, or remained elusive for some time. Now, nearly a kilometer away or so from Saruq 7 and this region of intense industrial activity and ritual ceremonial activity lies the site of Saruq 53. And we believe the answer to the question around the energetics of the ritual economy lie in this region. Now, this aerial image shows the current investigations as of early 2025, with focused efforts on a large mound of deposits rich in wood charcoal, circa 3 to 4 meters high and maybe 30 by 30 meters in total area. It's a very, very large distribution of charcoal deposits in this zone. The mound was covered in modern mobile sand dunes extending over about 12 meters or so from the archaeological deposits, which really serve to help preserve these areas. Now, SAR 53, Saruq 53, Site 53, was identified in 2007 by the local team during surveys designated to delineate the extent of Saruq al-Hadid and locate essentially related archaeological features in the area. And test excavations conducted in 2015 and 2016 by the local team revealed the intricate stratigraphy and pitting of the deposits and underlying basal gypcrete surface. In the 2018 and 2019 seasons, led by Dr. Mansour of the Dubai Culture and Arts Authority, expanded these earlier test excavations by a further 14 5 by 5 meters square trenches. And the team recovered materials that documented dispersed fire-altered sandstone cobbles and slabs, dense concentrations of charcoal and ash intermixed with animal bone, distinct Iron Age II slipped pottery forms together with these deposits, and later remote sensing studies, including gradiometric and ground-penetrating radar surveys, in part conducted first by colleagues in the University of Tübingen, and most recently by a team led by Diana Francis and Sonia Santos Asunsao from Khalifa University, confirmed the depth of the sand deposits across the site and provided evidence for potential subsurface anomalies across the area. Now, as first reported by Dr. Mansour and recently published in the most recent seminar proceedings, the upper layers preserved an intentionally deposited metal hoard, which was mentioned earlier today, consisting mostly of elaborate copper alloy vessels and tools, many of which with intricate incised designs. And this testifies really to the complex association of status-oriented material culture and extensive pyrotechnological activities at Saruq al-Hadid more generally. And I'll discuss the hoard a little bit in some detail later on because it really it creates a nice data set to compare sort of momentary deposits, very intentional deposits, and then the general sort of metallurgical assemblage in Saruq 53 more generally. Our work at Site 53, and in particular in the large charcoal mound, decided to really target in high-resolution excavations these stratigraphy. The work by Dr. Mansour really led and gave us a big understanding of what to expect. So we were able to go in and target each of these individual layers with careful sampling, with the dedicated approach to understand really the wood charcoal assemblage present there. Work that is led by Abigail Buffington and Lucas Proctor. It is an extraordinary assemblage as a result. Because the stratigraphy are so well preserved and the depths are so high, it really gave us a great opportunity to understand this window in time and really treat this mound as an archive, an environmental archive, an archive of culture history that gives us a good insight into really how the ritual economies could have been energized with these sort of materials. It's an unusual preservation. So the overall plan was excavations at Saruq 53. So from our combined excavations together with the work done earlier by Dr. Mansour, highlights that as you can see from this aerial image right here, that the basal layer of the gypcrete surface, this hard pan surface, is pitted extensively across this whole terrain. With scores of pits, many of which are cutting into each other, and some of them are as wide as almost 2 meters in diameter and about 50 centimeters or so in depth. These really form that basal layer. And then above this are deep sloping deposits of many layers of charcoal, wind-blown sand, and fire-altered sandstone cobbles, as we were talking about. And a lot of these cobbles are probably turned over remains of different reprocessing of these pits, both in the basal gypcrete, but also within the actual sediments of the mound itself. We have good evidence that there's through this mounding process and development and accumulation of all of these materials, that there's probably multiple mounds kind of coalescing through the course of this whole process. We can zoom into the stratigraphy a little bit more just to show what this looks like as one of the windows into this sort of space. You can see that basically below the wind-blown sand on the top, there are several layers of essentially wind-blown sand and charcoal deposits of varying densities of charcoal. There's at least probably 2 major mounding events that we can see in this particular deep section. And these are bracketed by periods of wind-blown sand. So a question really kind of emerges is how long did it take for these sediments to build up over time? And how long, what's the time depth involved in the production of this greater site as it's preserved? So another area, and I won't talk about it too much, but it's of course the laser is hard to see. So while the larger area of excavations there encapsulate a lot of the charcoal mound, as it were, we did target some excavations that were first tested actually by Dr. Mansour and later by our team in Area O, there in the sort of southwestern area, just to test and see how spatially extensive a lot of these activities are, but also are there varying kinds of activities in the area. And the preliminary results from this, and which I won't focus too much on in this particular talk, so that there is indeed different activities out there, material culture that's quite distinct from the charcoal mound, and also fabulously preserved and in situ pyrotechnological feature, probably a kind of oven built of mud plaster and a kind of gypsum plaster, proper plaster as well, associated with that, nicely in situ, which is quite unusual for Saruq al-Hadid more generally. It's a fabulous testament, I think, to the kind of preservation that we have in the area. Now, the radiocarbon from this particular zone is, I think, one of the more exciting elements of this. So in Area T, the so-called charcoal mound, we had already a good insight from Dr. Mansour's work to show that we have a real tight chronology, and we were able to confirm that with further radiocarbon dates. So we've assembled those, as you can see here in the right-hand image, and these are radiocarbon dates that are aligned and organized by their stratigraphic position within the mound. We then modeled these relative to their position within the mound to give us a first sort of insight into the span of ages. And the chronology, the radiocarbon dates from the top down into the bottom and into the pits of this mound really show a tight, like I said, a tight chronology, somewhere perhaps between 40 and 140 years that we can see right now within the deposit. So it's a large charcoal mound with a really tight chronology. And this is a really a great result that has come through the collaboration with our teams. Now, Area O has a slightly different chronological profile so far. Similarly, we only have right now 5 radiocarbon dates from Area O. This is the same place with that oven feature. From top to bottom, we're looking at a slightly extended range of dates, but still clearly within the Iron Age II periodization within Saruq al-Hadid more broadly. The mound itself is loaded with charcoal. And like I said before, we are very interested in the aspect of both speciating the charcoal and really trying to understand local ecology, perhaps distant ecology, and fuel acquisition practices. And I'll provide some of the preliminary results today about what that actually kind of looks like. Now, the work by Abby Buffington in the field, but also back in Baltimore, has been able to show that we have a real dense accumulation of charcoal within these mounds. And so we can see a charcoal density following across these different periods as we have. This is the chronology values that you can see there are just the phasing that we have within the mound. Show that we have a kind of a good even distribution of charcoal density across that space. Now, the different kinds of charcoal species that we have represented within the mound itself show a really interesting pattern, and one that has now forced us to deal with a couple of hypotheses around this distribution. So ubiquity here is essentially a quantitative measure to assess how frequently a particular plant taxon appears across different samples or archaeological contexts. And among these different species represented here, and there are many of them, it shows perhaps in a kind of interpretation that we can look at different regions that are associated with those taxa. We have desert plants that are woody taxa that are really related to desert environments, like Grewia tenax and Mura crassifolia, both very drought-resistant desert shrubs. Prosopis, which is extant through the region to today, and Tamarix as well. But there's also a lot of species that are that you would find in present day more commonly in wadi and montane regions. The predominance of Ziziphus or Sidr or Jujube is perhaps the most common of the species represented. There's acacia, olea or wild olive, potentially wild olive, which is known to the higher elevations of the Hajar mountains themselves. Commiphora as well, similarly, a Wadi montane species plant. Also potentially oases-derived species as well, pistachio. There's ficus or fig, in addition to phoenix or date palms that are presented within the charcoal assemblage as well. So this is a wide diversity of plant taxa that are represented, forcing us to really hypothesize whether or not we have a very different kind of environment in this latter phase of the Iron Age to sequence at Saruk al-Hadid, if we're thinking about local production of charcoal, or we're actually looking at the mobilization of wood resources and charcoal resources from distant and disparate regions, which tracks alongside a lot of what we already know about Saruk al-Hadid, knowing that ores, copper ores, for example, would have been brought to the far deep parts of this desert for production. So this is another element to this particular story, one that has answered some questions and provided a lot more, answered some questions, but provided really a lot more as well to this particular conundrum. All right. So in addition, I wanted to say this as well, this is really important, is that if you start to separate out different contexts, in this case particularly separating out the wind-blown sediments versus the pits that we have across the Saruk 53 or the charcoal mound, Ziziphus spinochristi in particular, this wadi species is found predominantly through a lot of the wind-blown deposits, but not found in the pits that we have been able to investigate in some detail. It's not to say that Ziziphus isn't found in any of the other pits, but those that we've looked at shows that there is a preference that doesn't include Ziziphus in those particular contexts. So this also gives us another sort of insight that perhaps the wind-blown sediments themselves that include a lot of the charcoal may indeed actually be involved with more of a consumption pattern, whereas the pits themselves are showing more of a production pattern. That gives us some insight into that. But we have a lot more work to actually detangle a lot of those particular kinds of patterns. I also wanted to highlight some other quick work, if I do have time, not much time, is that we have pottery in the area as well that in the charcoal mound that's really limited to small bowls. And the small bowls themselves are composed broadly of wares that are perhaps most consistent with those known from Eline, but there are other particular ware groups as well. This work by Matt Jameson in particular has been really important in driving this. And in the last sort of point that I will make, this is the second to the last point that I'll make, that among the metal assemblage, this of course is the hoard that's been now partially published and found within the mound, and comparing that to other kinds of metal objects that are found across this area, we can do compositional analysis essentially to look at the big differences among those. And I won't go into too much detail outside to say that there is a striking difference in composition, that the hoard tends to have quite a bit more tin bronze associated with it. The alloy distributions vary from hoard to non-hoard, and what we can really look at, and this is also looking at copper grouping, so if we get rid of all the alloying components and look at copper groups, there is a certain diversity as well. And strikingly important is that both alloy groups and copper groups, so the raw materials and the alloying technologies, show a lot more diversity in the hoard versus the materials that are kind of distributed around the site more generally, showing very different pattern in some ways about how the deposition of these objects versus the hoard rather versus the rest of the objects is seen as a marker through a lot of these alloys in the copper groups themselves. And the last point I want to make is that with all these collective patterns, another distinguishing characteristic of the charcoal mound is that there is a predominant reliance or a signal from domesticates here. This is a contrast with Saruk 7, where you have a lot of wild species represented, and wild species at Saruk 53 are quite uncommon. So you have something that's broadly contemporary, or the very sort of end of what you can see at Saruk 7, a very different scheme in terms of food, a tighter chronology in some of these areas, and a spatially discretized, another spatially discretized production activity that's happening within this greater, broader region that is the Saruk phenomenon more generally. So with that, I'll say thank you very much, and it's been a real pleasure. Thank you, Stevie.
Thank you very much. We have time for one short question. Is there any urgent question?
Thank you very much. Maybe you could explain a bit more, say, elaborate a little bit more on the formation of this mound. So to which extent do you see the aeolian deposition? There seems to be heavier material, so there seems to be also a colluvial input. Did you have a closer look at that?
Yeah, we're looking at some of these with an aeolian geomorphologist named Paul Hesse at Macquarie University. But what I can say for now is that a lot of this is actually is windblown sediment. The heavier materials there are all almost anthropogenic. It's turned up pit materials that are in there. So the formation of the deposit, at least in the window that we can see, it's really complex. I'll just say that. There's multiple mounds that we can see in different directions and profiles of how the charcoal is building up over time, and mounding, suggesting that there's activities outside of the area that we were working. So you see the pits that are very much on the bottom. But everything that we've been investigating is covering those pits, and so there must be other areas that are contributing to this mound as this is developing as a totality. So it's quite a large zone of activity, and what we're seeing is just this small window. And whether we're looking at consumption and production context, I think play a part in the site formation process here, because if indeed we're seeing production, that's probably limited to a lot of these pits, but there's a consumption profile that's going on too, because the mound is full of bone, it's full of bowls, and other sort of materials as well. There's little bits of beads and some metals as well, besides the one of the hoard, which is a bit of an anomaly, just to show that there's other kinds of activities that are more than just production in that sort of sense. So it's a complex phenomenon, but it's a buildup that is very narrow in time and probably, again, focus in the broader zone that build this thing up over time. That's what we're thinking so far. Thank you. Okay.
Unfortunately, we have to move on to the next speaker.
Oh, good.
Thank you very much again. Our next speaker is then Leda Düring, and he's talking about boom and bust in the Zohar hinterlands.
So it's a real pleasure to present at this seminar for Arabian Studies. I would like to thank the organizers and also for bringing the seminar to Arabia. My talk is based on a research project that I've undertaken between 2014 and 2024 in the hinterlands of Zohar, so just over the Hajar Mountains, some 140 kilometers as the crow flies from where we are today. I've been trying to publish the results in a monograph, and I've been thinking about all kinds of issues. So what I want to focus today on is whether we can reconstruct past demographics, population levels from archaeological survey data, and discuss some of the problems and potentials of those data sets. The Wadi Jizzi archaeological project started as a systematic surface survey of the Zohar hinterlands. We focused on documenting archaeological sites, structures, assemblages of all periods in two wadi corridors connecting the coast to the mountains. So the Wadi Fiz and Wadi al-Suhaimi in the north, and the Wadi Suk, Wadi Jizzi leading to Al Ain in the south. In these corridors, we documented all the archaeological remains through systematic tract walking, recording of all structures encountered, and the collection of diagnostic artifacts. Now the question is, can we use this archaeological data from the research to reconstruct changes in past population levels in the Sahara hinterlands. Now, of course, the topic of demographic reconstruction is something that archaeology has been discussing for a while, and various approaches have been proposed to do this. Until about 2 decades ago, the main approach was to use, in fact, archaeological surface data. Sorry, I'm already out of sync. Things like the number of sites and the aggregate site area per period as a proxy for past population sizes, as exemplified in this book edited by John Bindliff. Likewise, within West Asia, survey data have traditionally been used to estimate past population fluctuations. Especially popular is the so-called aggregate site area. So the total size of all settlements dating to a particular period, using the assumption that settlement size is a function of population size. And of course, this assumption is reasonable, but establishing settlement sizes for settlements in particular periods can be difficult. It is usually done by mapping the extent of pottery spreads, but when excavating, you often find out that pottery spreads are not directly related to site sizes. They might be smaller or larger. More recently, the use of the so-called summed probability distribution of radiocarbon data has been proposed as an indicator of past population densities. A large series of studies have been published along these lines, including a recent paper focusing on Arabia by MacDonald. And here the underlying assumption is that sites from all periods are equally likely to be investigated by archaeologists, and they are equally likely to be sampled by archaeologists, so that the number of C14 dates is a good proxy for past population levels. However, I think we're all aware in this room as archaeologists that research biases might greatly influence these kinds of graphs. And so they're not, unproblematic data to assume that past population levels are actually reflected by these. So if archaeological proxies are open to debate, what can historical data tell us about past population fluctuations? Now, we don't have a really good data set for Arabia, but we do have good census data from some other regions, such as Europe and China. And if you look at the data from before the Industrial Revolution, we see a series of boom and bust phases over the centuries, in which the maximum population is about 3 times as high than the population in the bust phases. An important caveat, of course, is that both Europe and China are in, well, most of it is in temperate climate zones, and there is a possibility that in arid landscapes, such as where we are today, where irrigation agriculture is essential for the production of food, the difference between boom and bust phases might potentially have been higher. But let's have a look what we can say. And further, as archaeologists, we usually start with a sort of pre-modern baseline to start thinking about past demographies. So what level of populations could have been sustained by traditional agricultural systems and the resources available in a particular landscape before staple foods started to be shipped across the world and agricultural innovations boosted agricultural yields. The place where we are gathered today, of course, is an excellent example of a population that would not have been possible in the pre-modern world, in which bulk foods were not shipped across the seas, apart from a few exceptions, such as the Roman Empire. The population growth of Abu Dhabi over the last 70 years is rather unprecedented, and if we want to get an idea of how many people lived in this region in the past, we need to start from the pre-modern era. And of course, fortunately for the Gulf, we have one good study that might give us an idea, which is the work by Lorimer, published a little over a century ago in 1915. Now, if we use the Lorimer data for the Sahara region, he says that there are about 20,000 people living in the Sohar area. He lists about 3,100 houses along the coast, which we can sort of translate into about 15,700 people, which would leave about 3,000 people living in the Sohar hinterlands, where we've done our surface surveys. In a recent study of 3 villages in the Upper Falaj al-Mutarid, which I recently published with Irini Bisseveld, we estimate about 500 people for that particular part of the landscape, which might fit with the overall estimate of Lorimer, and I'll just go into that a little bit more in detail to show you what that kind of estimate is based on. So here we see these 3 late Islamic villages, where we surveyed the field systems, the buildings, the symmetries of the villages of Miliene, Zaghlat, and Gurak. And we can look at, for example, the number of houses and estimate the population on the basis of that. So we would say that there are approximately 570 people living in those houses, but of course it's possible that not all these houses were occupied at the same time. We can also look at the size of the field systems using an estimate of about 25 people per hectare as put forward by G.C. Wilkinson, which would put us at around 470 people for these 3 villages. So I think from our archaeological data, the Lorimer estimates would probably seem realistic. I think that these data sets appear to fit. So I think we can start from the 20,000 as a sort of maximum baseline. And of course, the late Islamic period is also known as a kind of boom phase in the archaeology of Arabia. So in most surveys that have been undertaken in the region, this is an example by Nasser al-Jahwari, the late Islamic period is clearly a peak. We find a lot of material, a lot of pottery, and this can be replicated across the region in all kinds of surveys. And usually this is linked to a kind of economic phase where dates and pearls were really important in the world economy. And this is most eloquently put by Hopper in Slaves of One Master. Okay, so what can we do with the archaeological data from a survey such as that we undertook in the Sohar region? The benefit of such survey work is that we can look at a range of different data types across periods and see how they compare with one another. Thus we can see how the buildings, the graves, the sherds, and the chipstone assemblages compare to each other. And clearly some of these categories are more relevant than others. For example, chipstone is hard to date for most periods, and therefore overall it's not a great proxy for assessing fluctuations in population levels. By contrast, pottery is absent in the Neolithic in our region, not where we are today, and very rare in the Hafid. And so we cannot use pottery for those particular periods. So a lot of these data categories vary, the suitability varies per period. Now, if we focus for a moment on the sherds in particular, we can see the same peak for the late Islamic that we also can note in other surveys. And there's a difference of about a factor 10 between, let's say, the late Islamic and the Umanar, for example, and a difference of a factor 5 between the late Islamic and the Wadi Souk in the late Antique periods. But does that indicate a possible difference in population levels, or is that maybe too, is that also problematic? In general, it's apparent that the different indicators do not necessarily line up in our data. The Neolithic is only known through chipstone assemblages, the Hafid only through graves, the Umanar has buildings, graves, and pottery. The same is true for the Wadi Souk. However, in this period, we mainly have graves and fewer buildings. The Iron Age, by contrast, we have a lot of buildings, a lot of pottery, but very few graves. The subsequent late antique period, by contrast, is mainly documented again in graves, and the late Islamic period has a good amount of buildings, graves, and pottery. So the types of data that we have vary per period. And there are also, of course, some periods where survey data is just not providing a lot of data. So the late Bronze Age, the early Iron, the early Islamic are some of the periods that we hardly find in the surface surveys. So archaeological data only imperfectly represent past population changes. So I think we need to think about this in terms of an archaeological footprint. Like the carbon footprint that we use in the modern world, the amount of resources that we use per person can vary enormously. And this is also applicable in archaeology. In some periods, people were creating much more visible archaeological footprints than in others. This does not necessarily mean that there were fewer people, although we cannot exclude this either. So, of course, this is an example that is quite familiar with the audience, but consider, for example, Bedou societies. The mobile life way leaves a much more limited archaeological footprint than a sedentary farming community. Likewise, if people use things like leather or wooden containers, this again results in a much more limited amount of archaeological materials. And this is not unimportant. For example, a large part of the late Islamic ceramics that we documented in the field is in fact what we call incised buffware, and most of these shirts derive from water jars that broke in the field. So on reflection, what is by far the most consistent type of archaeological data in the Wajab survey is actually graves. We have a lot of graves in great numbers in many parts of the Sahara hinterlands. They tend to cluster in specific parts of the landscape. For example, on old river terraces overlooking the coastal plain. Such cairns have often been attributed to the Hafid period, but our survey suggests that these cairns date to a variety of periods. And generally, cairns are not often surveyed intensively and systematically in a lot of surveys, but we've done thousands of cairns in our surveys, and we've recorded things like dimensions, construction, morphology, location, associated finds, and so on. And if you do this kind of systematic survey, you encounter all kinds of patterns. For example, the cairns that you see over here, what we call oval terraced cairns, often have finds that we broadly date to the late antique period, so the kind of glazed pottery and glass vessels and so on. So on the basis of this type of work, we can try to identify cairns of various types and their distribution across the landscape, and try to say something about how these cairns might possibly be dated. Of course, dating of cairns by type is tentative, given that cairn types overlap, and cairns are often incompletely preserved, and some cairns are built actually on older structures that might not be visible on the surface. So it's all approximation. However, this type of systematic research that we undertook does allow us to characterize the cairns and other grave types in terms of possible populations. How many are there? Where are they located? What are their characteristics? How can they be dated? And I don't have really time to discuss all the different grave types that we've established or postulated in the course of the survey work, but we can identify a number of types dating to the Hafid, Umanar, transitional Umanar to Wadi Souk, Iron Age, Late Antique, and Islamic periods. And they can be differentiated with some confidence on the basis of their characteristics, where they are located in the landscape, so that we can estimate possibly the population levels on the base of these cairns, and we can use excavated evidence from other places to talk about how many people might have been associated with particular grave types, because of course some of them are single, some of them are multiple. Okay, so if we do that, so we can look first at grave totals, and then we get a picture that the late Islamic is very prominent. In the late antique periods, we have lots of graves. But of course, we need to qualify this with what kind of population levels might have been reflected by those graves. So suddenly, if we do that, the Umunar becomes much more prominent in the picture because there are many more people associated with a single Umunar grave. Of course, this is based on assumptions to date particular monuments to particular periods and how many people might have been associated with these graves. And then we can sort of also do this calculation per century. And then you get this kind of picture where suddenly the fluctuations are kind of evened out. It's a much more level playing field. And we see that, well, there are some differences between periods, but overall, we see from the Umunar to the Islamic period, we see slight ups and downs, but not very dramatic changes like you see, for example, in the pottery data sets that we have. And yeah, I think also this data would kind of fit with the difference between boom and bust phases, where the maximum population is about 3 times the size of the minimum population, possibly. So this is the data from census from Europe and China that I already mentioned before. It's of course, a hypothesis. I'm not arguing that the burial data that we have are actually a reliable and unproblematic proxy of past population levels in the Sahara hinterlands. For example, it's very likely that our totals for the late Islamic period are too low. Islamic burials are much less substantial than many burials from other periods, so we might have overlooked some of the Islamic graves. It's also possible that the ongoing use of Islamic cemeteries might have obscured pre-existing graves. Therefore, we need to compare these types of grave data with other types of archaeological data, such as yurts and numbers of houses, to contextualize these numbers. And of course, the more data sets line up in the same direction, the more robust a reconstruction of past demographic changes is. However, I do think that the grave data are probably the least problematic archaeological data set for reconstructing how population levels might have changed in the past, and seem to suggest a much less pronounced boom and bust pattern in population levels than one might reconstruct from other types of data. So if this is actually true, and this is open for debate, and I'm looking forward to your input, we could estimate that in the maximum levels, such as the late Islamic period, there might actually have been 20,000 people in this landscape, as suggested by Lorimer. And then in the period with fewer graves, it might go down to about a third, so 6,500 or something like that. This is all very tentative and open for revision, but it's the best suggestion that I can make on the basis of the data that I currently have to play with. I would like to end by thanking all kinds of people that have supported us, the Ministry of Heritage and Tourism in Oman, the sponsors like the BFSA, Leiden University, and private sponsors, my project members, and all my team members, and I would like to thank you for your attention.
Thank you very much, Bleda, for these interesting insights into populations. Are there any questions? Everybody's hungry for lunch? There's a microphone coming.
Thank you very much. I just have a question about, assuming population densities or generally population kind of dispersal, but what, like, are you accounting also, or how are you accounting for kind of markers of more mobile populations and ones that don't necessarily leave? I mean, obviously graves are one way of leaving a kind of occupation presence, but other occupational presences and how you're comparing those.
Yeah, so that is indeed a super important question. So if they're more mobile, there would be less houses, there would be less material culture. But some of the phases where we don't have these things, like for example the Wadi Souk is a good one. We do have some settlement evidence and some houses, but not a lot. We do still have a lot of burials. So it seems that the graves just continue even in phases where people might have become more mobile. So this is basically why I was suggesting that maybe graves is the best sort of indicator, and that maybe it's not like the landscape is empty in some periods of time. But it's really a question to you guys, does this work? I mean, this is my suggestion. Yeah.
Thank you very much.
Any other questions? If not, then I would like to thank you for your papers, thank all the other speakers in this session, and we reconvene here at 1:30, and now you can all leave for lunch. Thank you. exciting papers lined up. I'm pleased to welcome the first speaker, which is Najmuddin Morshed Hamza, and he will be talking about reconstructing the history, technology, and uses of pottery through the study of pottery sherds trend from Ras Al Khaimah archaeological sites.
Good afternoon, everyone. Thanks for Zayed National Museum for give us this opportunity to attend and present at the Arabian seminar and to be presented for the first time in the Arab region. My presentation, as you can see in the slide, is a project at the Department of Ras Al Khaimah. It's about conservation, about the reconstruction, the history and uses and technology of the material of pottery sherds coming from the archaeological site. My name is Najmuddin Hamza. I'm a senior conservation scientist at the Department of Museum and Antiquity of Ras Al Khaimah. It's already written at the slide. Our project teams, Ms. Hassa Shehi and Fatma Shehi, the project started at the beginning of 2025. Our application of the project will be on the site from Shimal, and it's applied on the pottery sherds come from the period of Omanar. I think it's all of you know more about Shimal. I think all the archaeologists know more about Shimal and Omanar better than me. For this, I will not go more further about explaining about Shimal, but what is important for us from this maps, that this is the previous research by Dr. Derek and his team, and they are explaining the kiln from different sites in Ras Al Khaimah. And this is important for us to know more about the manufacture of pottery in Ras Al Khaimah. And this is the old photo for Nar tomb. This photo was generated from the negative slide that were kept in the storage in Ras Al Khaimah department. And we generated this image from the negative slide. And this image from 1988. Go further for the research objectives. We have two objectives. The overall objective is to reconstruct the history and technology and uses and from the study of the pottery sherds coming from the trenches in archaeological site in Ras Al Khaimah. But the specific objective, as we can see, is to determine the characteristic and the provenance of the pottery raw materials and the technology process and the state of preservation of the pottery sherds itself. The more specific objective is to demonstrate the importance of the recovery and the study of pottery sherds from archaeological sites. As you can see, the pottery sherds come from the Nar tomb in Shimal site. It consists of 6 boxes full of pottery sherds. And our methodology for the project started from the separation and documentation for all the pottery sherds in the 6 boxes. And then we have to study and investigate the pottery sherds and make analysis for it. And then we have the result and discussion. The research methodology divided in 3 sections. The first section is the general grouping for the pottery sherds after documentation. And then we have a visual classification. Then we have a counting and typology and the shape and the surface treatment of the pottery sherds itself. Then we go further for the analysis. We go for the laboratory analysis and the technological study and the technological analysis for the pottery sherds itself. And then we finalize by the result of the analysis and go more further for the conclusion about the study of pottery sherds from Nar tomb. Here is the counting of the sherds coming from the site. Sometimes the counting for science might be not give more information, but it's actually can give us more evidence about the density of occupation of the site itself. But and also can give us information about and can interpret it with a comparison for the trench itself. And as we can see, the total number of the pottery sherds that we have it's 3,370. And the counting is divided, as we can see in our screen. It's from base and rim and handle and body. And what is the interesting here? It's from the 3,300, just 3 handle shards. And this is very important notice from the site. There's no more handle preserved. Can give us information about the type of object, or just can give us information about that there is no more excavation on the site, or what we can. This is what we will find in the upcoming slides. This is the only preserved completed object found in the boxes. And I have different type of pottery, but most of them is between small and medium size, no more than 20 centimeter in height, and 10 centimeter in diameter of the rim and the base. Most of them you can see in from orange to red color, and the only one in gray color. And this is very interesting, and we'll explain more about the technology for the material in different colors. This is also a digital documentation for the completed pottery shard. This is what we completed for the boots that we have from the boxes. And just for the digital documentation, we try to, not just for the completed boots itself, just we try to make a digital documentation for the shards to try to reconstruct from small shards to the complete boots. Different design we found from the boxes about the decoration technique and type. The first type is a painted decoration. The second type, incised decoration. And the third is a painted decoration on the raised wavy line. This is different 3 type. Is there the different 3 type can give us this is the different development at the time, or just all these types come from the same period? There's also different type of incised decorations that we have found in the boxes. And you can see, might be that the incised decoration can give us more information about the tools that the manufacturer, the crafts used during the manufacture of the pottery itself. Go more further for the decoration. Because we are familiar, and Oman it's a very popular periods, not just in Emirates, but I think in different sites in Oman and other sites. The typical uniform of decoration come from these lines. It's just wavy lines with the crossing lines. If you found in a pottery or decoration from Oman, you can find this similar decoration from wavy line and the crossing line in different shape. This is the second type of decoration that we have found from the boxes. There is a band around the neck of the boot itself, and come with a hatch between the bands, and also some decoration as a falling or line in different shape come from after the bands on the neck itself. The third decoration is the decoration of design. The manufacturer, the crafters try to make a design on the pottery itself, and you can see the different design. And actually, we are trying to make some interpretation from the design itself. How can the design of the pottery of the painted pottery shards and this design can tell us about the story and the history of the pottery from Oman site, from Oman time? This is a different shape of the rim. What is the popular from the different shape of the rim is a very curved or rounded out that the rim in Oman type. But what is the difference in the other sides is a different shape of the rims that we have found also in the boxes, but might be not related to Oman periods. Go further for the base. Most of the bases found from the boxes, it's flat bases, but different shape in the cross section, and only one cup found the rounded base. This is a different manufacture of slip of ingob technique for painting the pottery itself. It's found in the box. We have different type of painting, or that we can say slip technique on the pottery itself. It's the popular is the red slip. on the pottery pottery shelves that we have in the boxes, but we have also different type of slab that we have the craft is made. And also this photo, I think if it's not clear, yes, this one can show us this is that application of the red slab itself on the pottery itself. It can have the traces of it. And this is a different type of the color or the slab that applied on the shards to make it, or to color the object, or to color the surface to make another painting or another decoration. The technique of technology and making the pottery itself. And this is very interesting because the traces that we have found in some of the shards can tell us that it's a very advanced technique of manufacture of pottery itself. But we are not in a hurry because we are going further for the analysis. I will not accept these traces. Why it's not accepted these traces? Because the traces, the lines that we can see, it's very organized, and this can tell us this is the wheel throwing. And this is a very advanced technique of manufacture. And Oman it's very old, it's a Bronze Age. It might be not a very advanced technique. It might be it's a hand making. And the other is it's a wheel coiling. But we will just, we try to give interpretation what we have visual interpretation, what we can see from these lines. Reflectance transformation imaging technique. If you are not familiar with this technique, it's a technique used digital imaging, use a fixed camera with a sample in a fixed position with a multiple direction of light. The multiple direction of lights can, as you can see in the slides, the red spot can give you the different angle of the direction of the light itself. All of them can combine in a software of RTI, and you can use the viewer of the technique itself and give you more information about the surface morphology of the object. We can play it. This is the program after we make the digital imaging and combine. Yes. Yes, you can use different filter from the software itself and can give more information about the traces, the morphology of the surface. Yes, that we can take a result on a digital image from the software itself. As you can see, here is the traces from the finishing of the boot itself. It's not appear in the normal light, but with the RTI it can appear. This is the finishing of the boot itself. And also the thickness of the decoration of the line. You can see in the right side, there is no line, but in the left side, there is a line. This can give us information about the thickness of the pigment that the craft is used. And also this is the traces here of the thickness of the pigments. And also this gives information about how the craft designs the line. He make first the line and try to paint it over it. And you can see this is the line. He made it, and after this he painted as a traces line for painting. Also we can, from the RTI, know more about the design and the tools for the manufacture, for the crafts uses. And this is a different shape of the tools he used for making the inside design. Most of us can see this boot inside the site, the boot with a black spot. And sometimes it can give information about uses or technology. But in this case, especially, the suit is not wash off. if you try to clean it and remove, it will not be removed because it's from the body of the boot itself. And this from our example from the boxes, but this suit come from the manufacture technique. And this can give us information about the technology of kiln itself, because if you reduce or cut off the air inside the firing atmosphere, it will go for more black. If you add more oxygen, it will be more orange. And this can give us about the closed firing or open firing. This is the most important for us about the analysis for the pottery shapes from the sites. Our archaeometric study for the pottery shapes tried to find the fingerprints. Each clay and each clay for the manufacture of the pottery itself has a fingerprint. The fingerprint can give us information about the specific geography of the clay itself come from. Where does the clay come from? Because the fingerprint, if you make an analysis and get information and result from the sample, you can know the raw material where it come from. We applied different technique of analysis, but why we applied 4 or 5 techniques? Because each technique have to prove the result of the others, or might be remove some result from the others. He can accept or refuse, but at all we can get actual information and actual result about the analysis. This is the samples. The study applied 48 sample analysis in the different, was using different technique of analysis. And also this is a group of pottery shapes that we applied the analysis on it. Let's go for the first analysis, the petrographic analysis. Petrographic analysis is very important because we are trying to see more information about the morphology of the samples. It's just, you have to make a preparation, a special preparation for a very thin slide from the pottery shapes itself, preserved between 2 very thin sheets of glass. As you can see on the right, this is the normal cross-section. You can make it in your lab. It just, you can see the cross-section of the pottery itself. And on the right, from our group, it can give information about the raw material and the preparation of the clay itself or the firing technique. On the side, it can give information about the fine grain of the pottery itself. There's no more big grains inside the inclusion or the bust of the pottery. It can give information about the manufacture and the fine preparation of the pottery itself. I will give one example from each technique. Okay. One example from each technique because it's not possible to explain all the results. The first example is the sample what we have here, but what we can understand from this petrographic analysis. The first, the 4 image is for the samples. It can give us the information about the ground of the sample itself. It's a fine grained. It's a fine grained, it's scratched grained. It's prepared very well. And also, it can showing us it's a brown. It's a brown to dark coloration. This indicate for us the clay rich matrix for the material, and it's come from marley clay. The inclusion of the sample itself, it can give us more information about that it consists of quartz. And we will go further for the petrographic summary for all sample what we have applied. Most of the sample what we investigated by petrography, it's fine grained and highly porous ceramic, and the commonly material used in this ceramic, it's quartz and feldspar and rock fragments and iron oxide. And most of this sample, it's firing under low to moderate temperature of fire. We go further for the scanning electron microscope analysis. Scanning electron microscope analysis and energy dispersive spectroscopy is combined between 2 techniques: elemental analysis and image high resolution imaging. This is a scanning electron microscope result. We can see that we have both his high resolution imaging and also elemental analysis. He can give us more information about the elements inside the sample. What we can understand from the sample here, it's a very not very easy, but if you understand the morphology of the surface of the pottery and what we have inside this image can give us more information about the topography for the sample surface. This pores of the fragments, it's very clear, can give us information on the burnout of organic material or the gas is released during the firing. The other is the grains. The grains here, it's up. This is a very small grain, can give us about the sample and the crashing of sample itself. I will go more further. This is the result of the 16 sample made from scanning electron microscope. And the main component is silica, and the silica is a component for quartz. All the results come from the scanning electron microscope tell us we have three groups. The first group is a silicous aluminum with high iron, and the second group is calcareous with fixed rich flux, and the third group is a group which have a glazing layer, and this we have applied different analysis. We go further for elemental analysis again to confirm the result that we have. The XRD analysis, we are talking about the element analysis, but we have to confirm the compound itself, because we have in the previous slides we see silica and oxygen, sodium, but in XRD you have to, it will give us the components, the total compounds or the mineralogical data of the material itself. As we can see, the different sample, and most of these samples, after we analyze, give us more information about the firing of the pottery from the Nar time. It's come from between 800 to 850 degree. Thermal analysis, we try to approve what XRD give us. This is the actual methodology of the XRD. This is a different samples that we applied for XRD. And thermal analysis give information about different type of firing for the pottery shards. The first group, it's a high total mass loss. It's low fired ceramic. Most of the objects, it's low fired ceramic under 850. And the other group, it's a high fired ceramic. It's more than 850. And the last one is it's sometimes come between or below 800. This is a very interesting result that come from the technique. The only sample that we has found the composition of the pottery itself, he used soft stone grain during the manufacture. This is very special because there is no any evidence from all the samples or no more results in different research about that the manufacture of pottery itself added the grain of soft stone. For this, we have to make a further analysis about these samples. In conclusion, I know I will be in hurry for time. In conclusion, we are trying to summary what we have. And the technique and the material and the raw material from the pottery shells come from calcareous clay and also silica clay, and this can give us a geological context from Ras Al Khaimah. The result give us the multiple technology from the pottery shells itself, and also the pottery grouped in different group give us more information about the manufacture and technique. What we can say about the function from the pottery itself, it's not a very important functional uses, because the most porous samples that we have, it's might stored not very important or not more liquid material, because it's very porous samples. It can just give about normal storage for material, not very liquid. And also this can give us about the diversity of uses, and also about the diversity of firing. The diversity of firing and technique from the pottery shards result can give us if these pottery shards come from a development of technique or a changing in occupation of the site itself. And I would like to thank Zayed National Museum, because this project was funded this year from the museum, And also I would like to thank all people who support the research. His Excellency, the General Director, Mr. Ahmed Abed al-Taneji, the Director of the Department and the Museum of Antiquity in Ras Al Khaimah, in Jahala, the Director of Archaeology of the Department, and the Ministry of Petroleum in Egypt, because we applied the analysis there, and all members of Antiquity in Ras Al Khaimah. And thanks very much for your attention.
Thank you very much for this interesting overview in this project. I think we can have one short question. Is there anything pressing issue, anything you would like to know? There's no questions, then thank you very much again. And I welcome our next speaker, and this is Nuncia La Rosa, and she's speaking about personal adornment and identity construction across the late Bronze Age to early Iron Age transition in southeastern Arabia. Please.
Good afternoon. Thank you very much to the organizer for the opportunity to speak here about my PhD research on the ornamental assemblage from the funerary complex of the Balbaya in the Sultanate of Oman. This project investigates the cultural and socio-economic significance of personal ornamentation with a specific focus on beads and pendants. By adopting a multidisciplinary approach, it seeks to reposition beads as central archaeological artifacts, rich in symbolic meaning and capable of shaping historical narratives by shedding light on identity, technology, and long-distance interaction across the late Bronze Age, Iron Age transition in the Arabian Peninsula. In what follows, I will explain why bead matters, and then move through the archaeological context, methods, and some key results of the study. In archaeology, beads are everywhere, but they rarely take center stage. They are perfect for the cover of an article, but when it comes to systematic study, they are often marginals. Far from being minor finds, beads form part of a symbolic system that preserves and communicates non-biological individual and collective identity. They touch the body, signal belonging, status, gender, and age, and they often survive when bones do not. Even though they do not follow simple functional production logics and are not straightforward chronological markers, when studied contextually and with a multi-method approach, they become powerful tools for reconstructing identity and social memory, for tracing technological choices and cultural traditions, and for revealing long-distance exchange and social connectivity. Therefore, this research is grounded in a composite theoretical framework where beads are not only symbols of identity, but also practices: produce, exchange, worn, and reuse, and their technological traits and trade connection provide a window into broader processes of social transformation. It is from this perspective that I approach the Balbaya assemblage. The Balbaya is strategically located on the eastern coast of the Musandam Peninsula within the dynamic network of short and long distance exchanges across the Strait of Hormuz. It is one of the richest and best preserved funerary sites in southeastern Arabia and includes two monumental collective tombs, LCG-1 and LCG-2. LCG-1, the earlier of the two, was in use from the end of the late Bronze Age through the early Iron Age. LCG-2, larger and more architecturally complex, came into use during the final phases of LCG-1 and remained in use until the late pre-Islamic period. Together, the two tombs accommodated the remains of at least 468 individuals. The shift from LCG-1 to LCG-2 reflects broader transformations in funerary identity, spatial organization, and ritual behaviors. Among the thousands of grave goods, more than 13,000 beads were recovered, offering a unique opportunity to investigate diachronic patterns of ornament production and consumption. If we look at the overall scale of material from LCG-1 and LCG-2 tomb areas, ornaments clearly dominate the assemblage. This already shows shows us that beadwork was not peripheral, but structurally central to the mortuary system of the Balbaia. The 2-3 maps make this very clear. Ornaments, and in particular beads, stand out visually and numerically when compared to all other categories. Focusing now on personal ornaments, beads and pendants are the overwhelming majority, about the 95% of all ornaments. Most of these come from the LCG1 area, which contributes around 62%, while LCG2 accounts for the remaining 38%. Within this general picture, there are clear differences between the tomb areas. For example, rings increase sharply in LCG2, whereas LCG1 shows a stronger representation of items such as bangles. These patterns already flag distinct practices and possibly distinct workshop inputs. So, from this context, 3 guiding research questions emerged. First, how did personal ornaments in Southeastern Arabia reflect and shape social identities with collective burials, within collective burials, where the direct link between ornament and the individual is difficult or often impossible to reconstruct? Second, what can technological styles and raw material choices tell us about craft traditions and networks of exchange? And third, how do shifts in ornamentation across the late Bronze Age, early Iron Age transition relate to wider processes of social transformation? These questions converge into a broader one. Is an archaeology of identity possible in Southeastern Arabia? And can ornamentation serve as a proxy for understanding social change? Working with beads might sound like a light task, but in reality, it has been quite a challenge, not only because of the 13,000 ornaments recovered in the Al-Baya, but also because of the heterogeneity of their funerary context. To meet this challenge, I borrowed and adapted the systematic and multifaceted methodology developed and successfully applied in different contexts and periods by Professor Kenoyer and colleagues. And here, I applied this methodology at DIBA, combining multiple data sets, contextual reconstruction, and complementary analytical approaches. First of all, I focus on the full assemblage from the LCG1 area, complemented by representative sample from LCG2 to capture the late Bronze Age, early Iron Age transition. Then I reconstructed the excavation history and created unified databases, linking each bead to contextual data, raw material, typology, and photographs. I applied morphometric and technological analysis using SEM and digital microscopy to identify manufacturing techniques, tool types, and possible workshop traditions. Selected samples then underwent geochemical sourcing through laser ablation analysis, providing insights into raw material origins, trade, and interregional connectivity. And finally, I integrated all this data to refine site chronology, compare funerary assemblages, and assess the social and symbolic role of ornaments in collective burials. From the larger ornamental assemblage, I isolated 8,071 beads and pendants, which forms the core of this study. As you can see, almost all of them, 98%, come from the LCG1 area, while LCG2 is represented by a smaller but meaningful sample. Within LCG1, the majority derives from the internal corridor and the external pits. This step was crucial to define a reliable and comparable dataset before moving into typological and technological analysis. The first task was to build a solid baseline database, identify the raw materials, and create a high-resolution digital archive. This raw material classification became the backbone for all the subsequent stages of analysis. At the highest level, I grouped the assemblage into 4 macro categories: animal origins, stones, by far the largest group, dominated by mineral stones, metals, including gold, silver, and lead, and finally artificial materials, such as glass, past, and faience. When we zoom in further, the internal variability becomes clearer. Among animal origins materials, seashell beads are extremely numerous, over 900 pieces. indicating a strong coastal tradition of ornament production. Among minerals, carnelian alone makes up more than 3,700 beads, followed by agate and the other siliceous stones. This immediate points to long-distance connections with production centers in South Asia, where carnelian was a major trade item. Mineral stones overall represent almost 60% of the dataset, yet within this dominance there is considerable diversity with both exotic imports and locally available stones. Soft stones, especially fire hexatite, form another large group, more than 1,300 beads, reflecting a regional tradition of producing relatively simple standardized ornaments. Metals, although fewer in number, are socially significant. Over 340 gold beads, mostly small and standardized, underline the presence of elite adornment practices. Finally, glass past and faience had another layer of diversity, showing that synthetic materials circulated alongside natural ones. Beyond beads, the assemblage also includes pendants, stamp seals, and other small ornaments. Even if numerically few, these objects stand out for their highly informative and symbolic value. Taken together, all these materials highlight that the bead assemblage is not only quantitatively dominant, but also quantitatively diverse, embedding a wide spectrum of cultural practices and long-distance interaction. The hierarchical classification of raw materials formed the foundation for the next step, constructing a morphostylistic typology. In total, 37 different raw materials had to be systematized, and each belonging to subtypes, types, and broader macro groups. To handle this variability, I adopted a double protocol. The Arabian bead typology, developed by Markeneuer, focused on measurable attributes such as cross-section, longitudinal section, and length to diameter ratios. And Beck's classic typology, which remains the main framework for stylistic classification and was particularly useful for complex and rare forms. By integrating these two approaches, I created a systematic language to record, group, and compare the 8,000 beads. The first set of graphs shows typologies organized by material group. Animal origins, most beads are circular, short cylindrical, or barrel-shaped, reflecting both the physical properties of shell and bone and the relative simplicity of their shaping. Hard stones, here the variety increases from short barrels in jasper or diorite to more complex forms such as long cylindrical lapis beads with the wings, but overall numbers remain limited. Metals beads show highly specialized typologies, often granulated or decorated, reflecting both technological skill and symbolic value of the material. Glass past and faience provide a wide range of shapes with a strong presence of microbeads, suggesting mass production and perhaps imitative strategies of more valuable stones. The second set of graphs focuses on soft stones, mainly chlorite and steatite, which represent one of the most versatile categories. The graphs show that the majority of beads are again cylindrical and barrel-shaped, but with a remarkable proliferation of small variants, short, micro, biconic, convex forms, suggesting both experimentation and the ease of working these softer raw materials. Other colored stones, though fewer in number, reproduce the same typological repertoire, showing that shape traditions often transcend individual material categories. The next stage of the morphostylistic analysis moves into morphometric study of carnelian and agate. From the total of 4,510 agate and carnelian beads, about 800 were selected as statistically representative sample. For each bead, I recorded discrete metric attributes like length, width, thickness, and drill hole diameters. The goal was to move from simple typological description to quantifiable morphometric data, which could then be compared across bead subtypes. The resulting morphostylistic repertoire shows that common shapes include barrels, biconical, cylindrical, discoidal, spherical, oblate, and ellipsoidal forms. Alongside these, a smaller number of rare or unusual forms, such as lenticular, planoconvex, and axisymmetric types, also appear. Finally, two special categories stand out: bleach beads and the so-called ice stones, which represent deliberate technological and probably symbolic choices. In this presentation, I will show just one example in more detail: lenticular and rectangular beads. Lenticular rectangular beads. Using length to width ratios, I divided them into long, square, and short categories. This visual layout illustrates how standardized these morphologies are, despite superficial variations in size or color. Such a consistency suggests shared technological norms or templates in production. This graph plots the distribution of beads by their length-to-width ratio and the average drill holes diameter. It allows us to visualize how macrotypes cluster clearly. Long rectangular beads in green occupy the upper area of the plot, while the short and square types in orange and red dominate the lower part. These clusters indicate that the bead makers were working within fairly tight morphological parameters. If we now consider the drilling technology, the pattern becomes even more meaningful. To measure perforation regularity, I use the index of asymmetry of the hole, which is simply the difference between the two hole diameters normalized by their average. As expected, beads drilled unipolarly from one side tend to show higher asymmetry, while bipolar drilling from both sides produce more regular and symmetrical perforations. This technological choice is also related to bead morphology. Long beads, of course, are mostly bipolar as a strategy to avoid breakage, while short and square forms tolerate more variability and are often unipolar. So what looks like variability, in fact, is structure. Morphology and drilling technique are linked, leaving a technological signature that may correspond to the different workshops or craft traditions operating within the same funerary context. A detailed technological study of drilling techniques was carried out on carnelian and agate beads. High-definition silicon casts of the drill holes were made using dental impression materials, and around 3,000 casts were examined to document unipolar and bipolar technology. A selection of these casts was then studied under the USB digital microscopy and a further subset under scanning electron microscopy in order to define tool types and subtypes, drilling techniques, and where possible to identify specific workshop signatures and idiosyncratic trends. To quantify drilling technology, I use the tapering value, calculated as the ratio between the diameters of the two perforation ends. When we link tapering values with bead morphology, a pattern again emerges. Long beads are usually drilled from both sides to reduce the risk of breakage, producing more symmetrical perforations, whereas shorter or square beads often tolerate unipolar drilling, resulting in greater asymmetry. These consistent signatures reinforce the idea of distinct technological traditions and perhaps multiple workshops contributing to the Diba assemblage. Turning briefly to provenance, a subset of beads representative of the main shapes typology of the carnelian and agate Diba assemblage and group of the special category of the bleached beads was then selected for geochemical analysis, running at the elemental analysis facility of the Field Museum in Chicago under the supervision of Professor Kenoyer, Dr. Randall Lowe, and Lord Soubier. The preliminary results of the laser ablation have been compared with a database of geochemical signatures from 24 sources, and statistical analysis was performed to discriminate between indigenous production and actual imports and the geographic and cultural origin for these artifacts. In this first slide, starting with the bleach beads, the discriminant analysis of the sample of 17 bleach beads compared with the large available database shows that the raw material for the Diba bleach beads comes not only from India, but also from Iran. Stylistically, we can see subtle differences. Beads attributed to Indian sources tend to have thinner and more delicate decorative banding, while Iranian examples show slightly broader lines. In terms of drilling technology, all the Iranian beads in the sample were drilled unipolarly from a single side using tubular copper drills and abrasive, a technique also attested, though less consistently, on some of the Indian beads. This raises the possibility that at least part of the production took place outside the Indus region, perhaps in workshops closer to Iran. Here you see the results of the geochemical analysis of the representative sample of the whole carnelian and agate typology of DAPA shape. Using the same technique, we can see the result of the laser ablation and discriminal and canonical discriminant analysis. And here each point represents a bead sample or geological reference. And the clusters show us that most beads from DIBA group closely with the Indian reference sources, highlighting long-distance connection across the Arabian Sea. A few outliers, however, fall outside these groups, which may suggest alternative sources of technological treatments. What this tells us is that raw material sourcing was not random. It was structured, linking DIBA into the established exchange networks stretching to South Asia. As Turkey, Egypt, Southeastern Arabia, and Iran, they can be other possible raw material sources. To conclude, I would like to highlight 3 main points. This research demonstrates that a systematic analysis of large bead assemblages is both feasible and highly productive when typology, technology, provenance, and context are explicitly combined. It highlights DIBA Albaya as a keynote linking local softstone production with the Indo-Iranian exchange networks in microcrystalline quartz. And it argues that ornaments are not merely indicators of status or trade, but active material agents in the construction of identity and memory within collective burials, and that they deserve a central role in our reconstruction of social change in the Southeastern Arabia.
Thank you very much for this very detailed overview of thousands of beads that you have been studying. Are there any questions? We have time for 1 or 2 questions. Yes, please. The microphone is coming.
Thank you very much for such interesting presentation. Actually, I also was working with beads for many years, but I didn't know that some kind of etched beads could come from Iran. Okay, my question is about DIBA Albaya, because as you know, next to the DIBA Albaya is DIBA Al-Hisn, which belongs to Sharjah. And for many years, there are excavations in DIBA Al-Hisn. So did you use any DIBA Al-Hisn material for comparison?
Not really, to be honest, no. I would like to add that to my analysis, yes, and comparison. That would be great. Do you know, there are a lot of bleached beads from there because they are highly diagnostic kind of beads that they can be very useful for the chronology and also to understand better the topic.
In DIBA Al-Hisn, there is a lot of Indian material, okay, like Indian luxury goods, like ivory combs. There are some beads, but not etched beads.
Okay, thank you.
But anyway, I think this is the same site which is divided between two political ethnities, between Oman and Sharjah. And also there is DIBA Fujairah, which belongs to Fujairah, but the archaeological excavation is mainly conducted in Dibal Hisn, which is just near the border, with Dibal Baya. So I think it's the same group of sites, and of the same period, because Dibal Hisn is of Hellenistic and Roman period.
Thank you.
Are there any other questions? Oh, yeah, please.
Thank you. Thank you for the presentation and for the great work. Is there any studies being done on chemical analysis of the bleaching?
Not in my study, but yes, Professor Kenoyer. Not in my study, but yes, Professor Kenoyer developed also a procedure to try to understand how the bleach worked, and he performed also experimental analysis. Yes, and in his volume of 2017, you can find something, but of course, it's a topic that needs to be continued to study.
And do you have any plans to do more sourcing research for the other materials?
No, I want to finish my PhD before, but yes, that would be one of the most important things to do in Oman, because except for the work of Brunet, Charpentier, that they found an outcrop in the Emirates, we don't have any others outcrop in Oman, so yeah, that would be important to do. I hope not me. It was a huge
I see very many hands raised, but unfortunately we have to continue in schedule. But I'm sure that Nuncia will be around and can answer all your questions after in the coffee break. So thank you very much again. And we now move on to our next speaker, which is Michele Delias Posti, and he will be talking about the 2025 field season at Tel Abrak.
Good afternoon, everyone. Today we are just presenting a very straightforward report on our latest work at Tel Abrak, a site which I think is pretty well known. Let's say one of its key aspects is that it witnessed a very long human occupation from, let's say, second half of the third millennium up to the first centuries AD. And actually, we also had recently obtained a date from one of the graves that marks the latest use of the site, and is dated to the Sasanian period, to the 4th century AD. So this confirms some previous communications that we gave in a preliminary way, also here and at the seminar and here at the Abu Dhabi conference in past years. Actually, when we had to submit the abstract for this conference, we wanted to avoid repeating too many things we presented before. So it was an abstract made on, let's say, prevision, or what we were expecting to be excavating, and this luckily turned out to be quite true. In this first slide, it's just to show you the extension and the progress of works over the last 5 years, even so actually 6 campaigns after the first one that was very short and just really preliminary. You see that we have opened a very large extension, and this we think allow us to, to rebuild a more maybe clear from some point of view picture of the site, in terms that we are actually recognizing more and more buildings than were reported before. So this is also changing a little bit the picture of the site from one dominated by large platforms and postals features to one where we have a succession of several buildings. This is just to show you the areas where we work this year, mainly. And we focus, actually, the presentation will focus on the results related to two aspects, to, let's say, constructional program. Well, one is a constructional project, we think, and we define it as a platform system, which is different from is another thing compared to the white terraces, and actually it develops above some of those. I shall start by mentioning again this building one, which we presented before, also last year at this Abu Dhabi conference. This is a unique building that we now can better date thanks to a few more recent radiocarbon dates that are in press, actually in the proceedings of last year conference here. And we can kind of rather, well, not pinpoint, but closely place the construction around 1350 and 1300 BC. The point that the building was quite soon enough hit by a large fire, and that led to restructuring and then development of the area. And then it actually fell into partial disuse. And I just here, maybe I would point out that these other dates, I mean, the dates that are in bold, one dates the probable date of the fire, and then the other one marks a moment where the building in itself was no longer in use, and this can help us discussing the date of what I will show you next. And that is precisely this. So during what we think the early Iron Age 1 and 2, and I'm just referring to the conventional chronological frame that are indicated by this term. There's no other implication now. So let's say between 1100 or slightly later, we see that a huge platform, open-air platform, we are sure of that, was built above the buried remains of Building 1, actually exploiting some of his, if it works, yeah, but it's not, yeah. Here, it actually exploited the crest of this wall, I think for which we have evidence in the form of plaster. It was replastered to serve as a boundary for the platform. This platform also, this was already shown before, was equipped with some features on top of that in the form of smaller platform, which probably hosted some removable item. And also the other characteristic thing is a building technique which makes an extensive view of a very, very hard plaster. It is really cement hard, even today. And if you see in the bottom picture here, also the core of this structure was made in a very peculiar, using a very peculiar mixture of a pinkish clay with a dark gravel used as an inert, let's say as grit. And this actually can help us draw some connection with other structures at the site. So this platform was not isolated in itself, but seems to be, well, not seems to be. We are quite sure that at least in the area in the bottom part of the picture, it was connected to further platform which slowly climbed up the slope of the mound as it was in that period. And we also think that it was much probably connected with this other structure that we will see in a moment. And it is, and this is, we think, is quite strongly indicated, as I was saying, by the construction technique. This is just to show you the platform here on the side of the main one, and you see again a series of large steps, open air, as I said, because these short walls here, actually low walls here, are not collapsed, but really they were sort of corbs more than walls. So just defining an open air area, which is consistent also with those, let's say, podium bases, or how you want to call it, which I showed before. Sorry. And then we come to this other area where another, I think, quite unique part of the site was exposed in the recent years, where we have this monumental staircase, again made in the same technique, the same really hard plaster, the same material for the core of the walls, and the lateral support for the steps. And you see here that it also exploited or was supported. I mean, the difference meaning with this that we are not really sure yet if this huge walls that you see underlying the staircase were built on purpose or if they exploited some of the earlier platform, because during the second millennium it's been published before even by the team of Peter McGee, you know, that around and against the original early Bronze Age tower, a system of very, very large terraces was built on top of the debris, which is also helped actually preserving the early Bronze Age context. So we don't know, but it seems that at least this wall here, I don't know if you really see the pointer because I barely see it. This wall was probably, if I do this, maybe you see it, was probably intentionally built to support the platform, while the other ones, which are really, really substantial, I mean, this wall up here is more than 3 meters high. The previous wall probably belonged to this modification of the hill of the terrace system during the earlier phase. And I would just like to point out that actually this wall here, you see on the side of the spot, was one that was initially interpreted as being part of the Umanar Tower, which is why the Umanar Tower was reported to be 40 meters in diameter, but is clearly not. I mean, we are sure about that. And actually, I think that also in the thesis of Diane Barker, it was already pointed out. So actually, this staircase was leading uphill, and then a very few scanty remains of plaster, which you see, I indicated in the top right picture where they are in the context, in the general context of the site. This indicates that this platform system really extended up to the top of the hill and went on to incorporate the large mud brick platform that had been built in the late Bronze Age or maybe very, very early Iron Age, standing to the latest interpretation that already Dempos gave. And so you see that this system extends all over the eastern side of the tell, was so-called tell, and the peculiar building techniques which I mentioned before also allow us to include in this picture some of the structures which were excavated in the past. And you see in particular here, this is what was called the extension to the platform, and then another wall of less clear nature here. And this would make this part of the site, at least, because actually on the other side, the situation appears to be completely different. Really, we can interpret that as probably a place for communal gathering. We don't want to get into the details of what they could be doing there because we have no evidence. We not necessarily think about cults or whatever. And actually, the possible age of these two, which we return later, would really fit well with the evidence that was collected on the Sharjah side a few years ago, specifically on the flat area surrounding the site, where it seems that there was a boom of activity really in the late Bronze Age and a very early Iron Age one. And this would actually be sensible, because if you think about this, how visible Telebrac is still today, and to the extent that Federico Borges, when looking at all the satellite pictures of the 60s, could really spot out a white dot lost in a sea of sand dunes. So this must have remained a substantial landmark for millennia for all the population along the coast, which as also was reconstructed, also based on the excavation in Almeria, consisted of several very ephemeral, possibly temporary campsites. And so it would make sense that this, at least in this phase, Telebrac represented a gathering place for all this population that left evidence in the form of dumping pits and fireplaces, many of which were radiocarbon dated by the international team led by McGee. So while this was one of the two things we wanted to investigate this year, the other expected find was a new building of which we started to see a little corner last year. And finally, it was there, and it was not the only one. So this adds to our picture of a site where actual buildings were in place. So not all of the buildings that you see on this very colorful sketch are contemporary. Actually, maybe none of those. The interesting thing is that they span different periods, and for example, the one on the top are dated between 350, 150 BC, and while the others are more close to the early Iron Age or Iron Age period. B3 is a late pre-Islamic shrine that we discussed before, and so on. And maybe this might make of the site a place where you can at some point test the boom and bust theory that Bleda presented before, with the caveat that you're not going to excavate all of the site at the same with the same intensity, because you cannot really remove all of these structures. So last year, the previous year, we had discovered a little small corner of this building, which is ended up being called Building 11. And then, as we extended the excavation to reveal its layout, we also discovered another adjacent building. This was quite unexpected because, as you see in the bottom picture, this area was, they used to spend the weekends climbing up the hill with four-wheel drive. So, and these buildings really lay below a few centimeters of of sand. So actually, we think this was quite a fortunate finding. The two buildings are, you see the final, almost final situation of how we were able to highlight them. And actually, this I prepared this morning. So, and actually, in Building 11, we were able to define two main building phases. The first one is actually quite peculiar, because I marked it out in the lower picture because it was a bit clearer. But you see that in the beginning it was a C-shaped building with an open side, and also the associated use surface is consistently interrupts on the same line of the walls. And then a later wall was added to modifying it. But then you also see that on one side we had all these pits disturbing it, and we were, well, let's say, hoping that it could be burials, but actually they were absolutely devoid of any material. From this building, actually we differentiated three use surfaces, and luckily enough, some pottery was found which can be associated to each of those. You see here typical late Bronze Age pottery, and I'm particularly interested in the cup, in the basin on the right, because it displays a slightly different fabric, and also it recalls shapes which we found in central Oman with very early dates. So actually we quickly drawn the pottery. You see, is not too much associated with these levels, and actually from among these ones, I would like to point out the third shirt from the top on the right hand, because it belongs to one of those so-called trumpet-based vessels, which we discussed before, and with a very peculiar fabric, and possibly produced in Iran. And to the same category actually belongs the incised shell on the left, of which I provide another larger picture, only because I saw that a similar cup has become a kind of a star for the Zayed Museum, which is also in the banners along the road. So it's open to interpretation. Hélène David, that was by chance visiting us when we discovered that, as ideas. It can be maybe a map of a phallage system. What is peculiar and new is that here you would also have the possible portrait of the trees, which, by the way, you see have a very peculiar shape, not the shape you would expect from palm trees or anything that you usually can see here. So we will be studying that, and I don't know. Given that it belongs to this category of fabrics that are probably produced in Iran, it might also be connected to some tree species of the other side of the Gulf. From one of the floors, actually, the latest floor, we also collected a number of these, let's say, I mean, disc. We could call them stone discs, plus one pottery one, which were obtained by reworking calcite, soft stone vessel fragments, and actually Eric colleged them. We had a first look at the material from Tel Abraq, also correlated some of those to early Iron Age 1 typology of vessels. We call them tokens because actually, I mean, they have not the weight, not the shape to be real spindle holes, and usually this kind of shape is referred to as tokens, even though, to our knowledge, it's not something that is been much discussed in this area. This is just a picture of the poor building 12. You see it's very poorly preserved. It is interesting because it comprises different building techniques, mud bricks, small stone foundation. Also the shape is quite peculiar with this S shape with two rooms apparently facing opposite direction. But you see from the bottom how thin the layer covering it was. So I think it's already a miracle that this much survived. Actually, these were not the only buildings we discovered, and on the opposite side of the 1990 trench excavated by the Dempos, which is a huge thing you see in the middle, huge hole in the middle. The remains of another building were discovered. I would also point out the substantial wall in the back here, which is actually our three walls built one another, and that really display this terrace system that was developed in around the original tower. Also from here we have pottery, and again we have an example of these trumpet-based vessels. And just to remind you of, we already had some or several of this type, and notably including these two with cylinder seal impressions, which have already been published. So when it comes to the what new this tells us about the general reconstruction, apart from the single findings themselves, we actually have to already revise what we published in the as a result of last year's seminar, and we are now able to redefine a little bit all these phases in the use of the site. So starting from building 1. Building 5 is a small building which we may have to reconsider. The pottery is really the same as the one that I showed you from building 11, so late Bronze Age, quite distinctive. And then we pass by a phase in which there seems not to be any dwelling, any residential structure, where this large platform system develops, to then again turn to a domestic use of the site. indeed, one of the things we will have to try and sort out is there coexistence between the platform system and some of this building or not? And then I didn't show this today, but this also helps us refine the chronology for a sort of a renewal of the terrace system that we presented last year, built on top of the earlier one in a much more poor way with simple dry stone walls. And even in that case, probably running up to the top of the hill. Before we have the last thing we mentioned today, a small domestic occupation with typical so-called Iron Age II pottery, which again might indicate a period of shrinking in the population of the site. So that's it for today. Thank you.
Thank you very much for these updates on Tel Abrak. We can squeeze in one short question if there's anything urgent that you want to know. Yes, there is one urgent question, I see it.
Thank you for a very interesting presentation. Actually, my question is about your poster, which is
okay.
Yes, about the coins on your poster, because Tel Abrak site is also divided between Sharjah and El Kaiwain, and the coins which you show on the poster, they clearly belong to much later period, which you have here in the structures. And on Sharjah side, there were no any ABL coins from Tel Abrak, but there are some a lot of from Leja.
Yeah,
so did you compare this with the material of the Mleja, and to which types, according to classification, do you divide your coins?
Oh, so actually, as I said, they told me to keep it short. So they belong to a period of that it witnessed in Tel Abrak, which I didn't mention today. We presented it last year. They are probably associated to a small shrine, Building 3, which I showed before, which is dated to that period, and it comes along with a series of exceptional material. One is the statue that you see at the second floor, and yes, we are studying them. There has been a very preliminary attribution to known types of ABL coinage, but the numismatist still has to see them because she has been busy with the golden Roman aurae that we found together with some of them. And also this poster is a first step. So we have 24 in total coins, ABL coins, and we will develop the analysis of all of those and then proceed to proper typological classification when they are readable. And maybe we can see if the unreadable one can be classified on the basis of the composition. So this is a work that we are developing with Delphine Civilet of Sorbonne, Abu Dhabi. So.
Okay. So and you have plans to define them according to POTS classification? Yes.
Yeah, basically yes, or Caillot. So we will see that.
Okay. Thank you. Thank you very much.
We have to unfortunately move on. Thank you very much again for your presentation. And now I invite the last speaker, which is Michel de Vries, and he's going to talk about Iron Age mortuary practices in Southeast Arabia.
Hi, everyone. Thank you for being here so late after 3 intense days. So, let's see. Yeah, I'm going to take you from Tel Abrak right to the border of the Emirates and Oman, to Qatar and Al-Ain, where we've been busy excavating Iron Age funerary remains that had been first discovered in 2021 during a rescue excavation project led by Peter Sheehan and his team, Mohammed Khalifa and Noor, when they constructed a new border wall. And they came across a monumental tomb, late Bronze Age tomb, reused into the Iron Age, but also some Iron Age tombs. And it was decided, because the whole area is under development, it was decided to continue excavating there in 2024. to be ahead of potential future developments and to better understand the Iron Age funerary landscape. So we excavated for 6 months in total, quite a few large trenches, of which one trench you can see here, Trench 1, that had these, what we now understand as shaft type tombs that have been heavily looted or at least dug into at a later stage. And it's clearly a new type of tomb that has not been really documented from the region. And they have probably been disturbed during the middle or late Islamic period when people went back to the area to develop heavy agriculture that's all over Al Ain in a way. And they came across these tombs and have been quite systematically looting them. But fortunately for us, they were interested in only certain things and have left a lot in place that we can still study. So up to in Trench 1, we have about 10 tombs that we managed to excavate. But we're currently excavating even a larger trench of 100 meters long, and there's a lot of these tombs. We have at least 60 outlined, and there's a lot of tombs to excavate still. So it's very much work ongoing, and we present a little bit of the ongoing work and our first thoughts about what these tombs mean and what they could tell us about the Iron Age life in the region. So some research questions and goals are actually, up till now, especially from the Al Ain area, we knew quite a bit about domestic Iron Age structures, about sort of monumental caravanserai-style buildings like Hilly 14, but the funerary remains had never been really come across, and it's our goal to see what these mortuary remains might tell us about the Iron Age population living here. And already it's quite obvious that there's a lot of elements that we usually miss from settlement sites that we actually find within these tombs. So it's a very good additional picture of the Iron Age population to have, and it will allow us to ask different questions and to combine several methodologies to come up with new insights about the Iron Age population. So here you can see some of the initial images already of the ongoing excavation, and I'll show you some more now. Yeah, quickly, the historical and geographical background. As mentioned, Iron Age tombs or Iron Age 2 tombs are quite rare, actually, and usually actually in the region found in the reuse of older monuments that, for instance, Steffi has written extensively about as well. So in Northern Emirates, you find Iron Age burials within earlier monumental building tombs. And in Oman, you find these so-called honeycomb tombs or other stone-built tombs. But shaft tombs dug into the substratum are quite rare. In Kusais, there's a type of tomb that is actually excavated like this, but the Al Ain examples, like we will show, are slightly different. So here are some images of what they look like, and at the top image you can see that's the entrance to the shaft that has been dug into at a later period, and then you have this hole opening up to the side. And what we, one of the ideas we're playing with is that the way these tombs are constructed are quite tightly, closely related to agricultural practices, especially fallage irrigation that's very well documented from the Al Ain region. So the idea is that the principle of digging down into a harder gravel surface that's quite compact and then digging sideways to create a chamber, the knowledge of being able to do that and knowing that your chamber won't collapse might be quite closely connected to fallage construction where similar principles are followed, which means that there's a sort of potentially sort of co-evolution of the development of fallage agriculture, actually subterranean fallage agriculture, and tomb type construction. And this might be one avenue of looking at this new data, together with the transition quite prominently from monumental tombs in the preceding Bronze Age to Iron Age 1 to suddenly these shaft tombs that are smaller in size and as far as we can say only contained single individuals or maybe a few. So far we have only documented 2 individuals. So tomb architecture, you can see here, that's Michaela Walker, our osteoarchaeologist, inside of one of the tombs. So there are shafts that are dug down and then dug sideways in a compact gravel. And then afterwards, they're blocked by mud brick and some stone plinth structures to close off the tomb. And what we usually find is either that blocking wall completely having been removed due to looting, or sometimes left in place, and they only dug specifically into the chamber where they knew they had to be. So this is the typical way they were constructed. But there is also a bit of variety now apparent, especially in the last few weeks of us having excavated in the area. And you can see here at the top, for instance, is a smaller tomb with a niche dug to the side, which is a bit reminiscent of actually later burial traditions where the shaft is dug and then a little niche is created to the side. And we have quite a few of these that are quite small as well, and often contain only a few objects, like the lathe-turned softstone bowl you can see here, which is interesting in a way because it's also PIR, so later, so we can also already say that this tradition of tombs continued in the PIR, but there might have been an evolution in certain types. And for instance, the picture you can see at the bottom shows a shaft, and it has 4 little niches to each of the short sides. And as you can see, there's a long stone fallen at the bottom. And one assumption is here that they dug a shaft straight down, placed wooden beams within those niches, and then placed stone slabs on top of it to create a burial chamber. So it's also quite possible that there was quite a quick evolution of different tomb types developing from the shaft tomb types within the Iron Age already. But we need to gather more variety in this sense and more dating evidence as well to say this conclusively. Yeah, so our methodology, quickly about our methodology, is that although they are looted, we excavate even the backfilling of the shaft and everything as well as we can to understand the whole process of these tombs from their construction to when people re-enter them and how they were filled up again. And also a tricky thing is to excavate inside of the tombs because they're quite confined chambers of maybe up to 2 meters in width and 1.5 to 1.7 meters in length, so sort of oval shaped. So, but our point of view is to keep them structurally as intact as possible, to document them like this, and even, if possible, preserve them like this, because they're quite unique monuments. Right. As mentioned, they've been targeted by looting quite heavily, but as it appears, this was very targeted looting, and they were only interested in a certain amount of things, and that's probably gold and silver that might have been interred, because we only find very, very few evidence of this kind of artifacts. A few beads here and there that are left behind, sometimes under the mud brick wall crumbling down, or that has been sort of broken down. But besides that, they left a lot of things virtually in situ, especially on the sides of the shafts, as you can see here with these copper vessels and softstone vessels that were placed in the tomb with the interred. And we often find these quite well preserved in situ. So this gives us a perfect insight in at least part of the burial assemblage, and it's quite key. And already it's very obvious that these burials were they were quite rich. They were very rich. It's all kinds of objects you usually don't find on domestic sites, or at least we haven't really found in Al-Ain that much. But you find, for instance, in Saruq al-Hadid a lot in terms of luxurious objects, but they're also here in the tombs. So there's already an important insight that some of the objects missing from settlements are clearly in tombs, and population had access to them. Yeah, what we don't see here is the gold foil we find, sometimes littering in the backfilling of the tomb, which suggests that precious objects, particularly jewelry or weapons with gold, gold foiling on the handle, were quickly dismantled, and this was taken away. And a lot of other objects were not really particularly seen as of interest, including copper vessels that were largely left inside, sometimes fragmented, but sometimes complete. Now, as far as we know, from the tombs where we have actually human remains, partly articulated, and these are really the cases we look for, because then we can start saying things about the population and the people that were buried in these tombs as well. The tombs contained up to 2 individuals, and in one tomb, as I will show in a bit more detail in the next slide, we can actually say a bit more about the people that were interred here. So that's tomb 4, where 2 individuals were in a flexile crouch position, and there was an adult, young adult, and a child. And sex estimation was not possible, but future analysis might help us with this. At least there's teeth preserved of the child, which might help determine some of these details a bit later. But in general, there's quite poor preservation of the bones. Although we have noticed that when the bone is touching copper vessels or even manganese that's used for pigments, it helps preserve the bones, and this is an interesting little detail as well. So finds that are found are partly left in situ. As you can see here, there's beads, there's a lot of beads, as we have seen in the previous presentation, and this kind of find category is largely still available. Ceramics, small bowls, and a lot of copper vessels as well. As you can see here, there's a unique little copper vessel with a bird perched on the side that's now in the Zayed Museum, actually upstairs, visible or exhibited. And this is from a tomb that might have been already slightly later within the Iron Age, and we have a good C14 date suggesting that this kind of very intricate copper working is already slightly later in the Iron Age. So this is a reconstructive drawing of tomb 4, where these 2 individuals have been found. And you can see that objects are largely placed along the side of the tomb. The human remains were partly articulated, which allows us to give some more details. As you can see, there's an adult, which at the back had this cluster of arrowheads, which we'll get back to in a minute. And then there's these quite classical, as it seems now, objects of shells, shell tools or for pigment, copper vessels, including spouted vessels, soft stone vessels, lidded soft stone vessels, little bowls and spouted bowls, and small bowls, usually small ceramic vessels, no real big storage of anything. And what is particularly sweet and of note is that the child that was buried at the feet of the adult, at potentially a slightly later date, although this is hard to determine because the tomb was looted, so some of the information might be disturbed in that sense, had close to his hand had 6 astralagi, 6 knuckle bones that we know from other cultures are used as toys or as sort of dice, and it's likely that this child was clutching these knuckle bones when interred, as probably his own toys, little toys. As you can see on the picture at the top, where they're indicated, actually the fingers of the child and the knuckle bones. Astralagi. Right. Dating-wise, we have 2 C14 dates now. They're a bit hard to come across from good context, but we've been lucky to get good dates, which firmly put this burial tradition in the Iron Age too, continuing to slightly later Iron Age too as well. And from some of the material culture, we already know that these tombs definitely extend into the PIR period afterwards. And actually, a few hundred meters to the north of these tombs were Sheehan's tomb found sort of these more monumental lime-plastered PIR tombs. So this cemetery by now appears to at least have continued into the PIR and might have already started in the Umanar period. Because what I forgot to mention is that in a monumental tomb that Peter Sheehan, for instance, excavated, Umanar ashlars were reused, and clearly Umanar tombs were available in the immediate area, or were standing in the immediate area, but probably taken apart in the late Bronze Age to build later tombs, and even in the Wadi Suk period, for that matter. So we have a long-standing funerary land, or a long-lasting funerary landscape here in this Al Ain border site. Right. Well, some quick other on the tomb 4. Have you seen there was a cluster of arrowheads where you can see here that actually mineralized wood fragments of the shafts were preserved, and the outlines of the arrows could still be seen. So we decided to block lift this whole cluster, including the surrounding soil, because we have the suspicion that they might have been held in a quiver, as we know from, for instance, Mudmar and you know, in these sort of ritualized casted quivers, that arrows might have been carried around in quivers. So we hope with future analysis to actually to show that what sort of the organic elements were in these tombs that might partly have been preserved or hardly preserved. But we'll try to find out techniques to do so. And to quickly mention, arrowheads are really an integral part of every tomb, even if looted, we find arrowheads. So there's definitely something about arrowheads being interred either in clusters or even in these smaller tombs that we suspect might have been for children. 1 or 2 arrowheads are placed as well. So it seems a very, very key element of Iron Age burial rites. Some analysis has been done on a mineralized plant-derived material from some of the copper alloy vessels and the arrowheads by our Sarmont colleagues, Maria and Christophe. And some really interesting initial results already came up that the copper bowls might have been placed or might have been wrapped in what might likely be flax or linen. And the rope sort of used to tie the arrows to the shafts might have been of the palm family, so palm fibrous sort of threads, which is not odd, of course, in the context of Alain being one of the big oasis towns in this time. Some new results. Well, human remains have been quite hard to come by. I mean, because of the looting, it's often quite scattered and very fragmentary. But in recent days, we've come across a few other at least partly articulated burials, which hopefully will provide more insight to the people that were buried in these tombs. And the work is very much ongoing. Tomorrow we'll back into the field to look further into these tombs, to excavate them and further analyze them. And quickly about this coevolution of tombs and phalage irrigation. Here is Mohammed Khalifa standing in one of these Iron Age phalage systems in Alain, and they're littering the place. They're all over, crossing the town underneath modern construction even, and a quite almost claustrophobic sort of elements. When we get into them, you get a real sense of what it meant to go deep down into the earth, sort of almost, you know, a sort of eerie, underworldly kind of place. And you wonder what those concepts, when phalage agriculture was developing, what that did with the mindset of people's conception of these kind of things as well, and how that influenced tomb construction, not only in a technical way, but also in the way landscape was perceived. So, in terms of discussion and future directions, we are currently excavating a vast area in this funerary landscape as part of these sort of rescue excavations, with many more tombs. As you can see on the picture below, a big trench with a lot of them looted. Our hope, of course, is to at some point come across tombs that haven't been looted, but the issue and the problem of these tombs is that they will be hardly visible as well on the surface, which is another important insight in a way that for the Iron Age II funerary landscape in other areas as well, particularly where phalage agriculture is an important element of the landscape, these tombs might be around as well. But if you don't come across them by accident or by sort of development, then they will stay hidden. So part of the absence or the invisibility of Iron Age funerary landscapes in other areas might be because they're simply not as visible as previous monumental tombs, especially using stones and sort of monumental nature. And we hope that these excavations of these tombs will add to the information we have from the settlements, and with sort of high precision analysis of the elements we find in the tombs, from artifacts to the human remains, and try to extract as much information from these finds as possible. We hope to get a better insight about the lifeways of Iron Age population in Alain and also the wider region. to cover some of the research gaps that exist in our records. So quickly concluding is that there's a unique type of shaft-type tomb from the Iron Age, has now been found in Al Ain, but might likely occur in other places as well. There's already potential diversification of types of tombs quickly within the Iron Age itself. There's a clear continuation of this tradition into the PIR and maybe beyond in that way. Individual tombs are for few individuals, and this must mark, but this is for future research as well, this must mark a difference in social outlook relating to potential shifts in social organization and tied to changing concept of shared ancestry. You know, these communal tombs very much about creating a sort of shared, almost anonymous ancestor in a way, but then with individual tombs, there might be a shift in those concepts. The shift from monumental tombs to shaft tombs or individual tombs has, in other cultures and even ethnographically, been sometimes associated with social stratification and in different ways of family ties to landscape use, for instance. So all of these elements are to be considered. And it is clear that the burials were extensively looted, but only for certain objects, very particular objects, which leaves a lot for us archaeologists to work with still, which is it was a happy, coincidence in that sense. And as an idea is that this type of new funerary practices might have developed hand in hand with fallage irrigation in areas such as Al Ain, where this was a practice that was very much ingrained in people's day-to-day engagement with the landscape. Thank you for your attention.
Thank you very much for these new insights into lovely Iron Age tombs. Are there any questions from the audience? Bleda.
Thank you. So, if the graves are so invisible, how did the looters know where to go? Was that some kind of marker, or how would that?
That's a good point. So we often find these limestone slabs, but they're out of context. So it might have been that the tombs had been marked on the surface. But it's also quite obvious that we find channeling and we find tree pits being excavated from this middle and late Islamic period. So it looks very much like at some point they stumbled on some of them and they saw the potential, and then they found ways of digging. And in the new excavations, we can almost see them tunneling through the landscape in a way, finding new tombs to loot. And then when you hit this sort of mud brick wall that was blocking the chamber, they knew they had a new one, and they sometimes just skipped the wall and went straight into the chamber. So it appears that they became very practiced at looting these things. And they might have been marked, but we haven't found an intact one to suggest this, although stones might have been put on the surface. What ties into this is it's interesting that we find these shaft tombs often quite closely together, and even shifting orientation to be able to build the two tombs next to each other, or else you would be digging into a different chamber of an earlier tomb. And that implicates that either that this was done, with very little time passing between these tombs being excavated, or that people knew where they were. And if that's so, then they must have been marked on the surface in some way. But we just have to find intact ones to really, really prove this.
Any other question? Yes, please.
Thank you. Is it in any place visible where the original surface was in your stratigraphy, approximately at what depth they were cut?
Yes, it is. Yes, because the chambers were dug into this quite compact gravel, and then the original surface of the chamber tomb is often this sort of very compacty, almost lime plastery surface. So that's visible, and it's 2 meters down or even further. So the shaft went down maybe up to 1.82 meters sometimes, and then the chamber extended slightly lower than that, even with a little threshold, and then a mud brick wall that covered it. But yeah, we find the original surfaces of the tombs. Yeah.
Do you have any idea what kind of landscape they were dug into?
In what sense? What do you?
Was it an abandoned field or something?
Yeah, yeah. Well, this is another question. So we're not far off. So this is it's currently on the border, and it's sort of on the edge of this extensive wadi fan, and then Buremi is just to the east, and Qatar Oasis is only 100 meters to the other side is where it starts, or well, a bit more than 100, but not a few hundred meters, and the Oasis starts where probably the Iron Age settlements would have been. So it might have been that this was always sort of a liminal area, in a sense, between different settlements, and it very much appears that in Al Ain, settlements were nucleated in various areas that are currently, a lot of them are in where the current oases are, from Qatar to Jimmy, so different communities with their cemeteries, but this one might have straddled sort of not exactly no man's land, but a sort of a liminal area between these settlement nucleus. Yeah.
Thank you.
Any other questions? Yes, please.
Thank you very much for your presentation. I would like to ask you about, do you have any traces of tool marks on the shaft wall, or you have any other plasters? Or thank you very much.
Yeah, it's a good point. Well, in a way, the shafts are often dug into at a later stage, so we miss some of that information in the softer marl. And when it comes to the gravel, it's hard to recognize this, but maybe it's something we have to look at in a bit more detail. But it's quite compact, but it's also not that hard to dig into. So it might have been a bit too soft to really see those kind of tool marks. What is clear is from the mud brick walling that there's a lot of technical information there. The interesting thing there is that they differ from tomb to tomb. So some use quite well-constructed mud bricks, others just use a bit of almost wattle and daub style kind of thing with some stones thrown in. So that looks very much like up to individual choices or families that did it in slightly different ways. But we still have to look a lot into the techniques of constructing these tombs. Yeah.
Thank you very much.
Are there any other questions? If not, I want to like to thank you for your talk and all other speakers of this session. I would also like you to remain seated here because there will be some closing remarks by Peter McGee, who is on his way. So you have to wait for a little, but then he will be here for the closing remarks. Thank you.
Good afternoon, everyone. I wanted to just offer some brief concluding remarks to the 58th Seminar for Arabian Studies. I can see that there are people still outside enjoying the hospitality, and that's okay. In the 3 days in which the seminar has taken place, I've witnessed that papers have moved beyond reportage, the discovery of objects in excavations, to exploring themes that examine economic and social life in the past of the past inhabitants of the Arabian Peninsula. This is only possible because of the extensive fieldwork that's been carried out over generations in this region. So while the discipline may be shifting, that shift is only possible because of the archaeological research which has been done by people, some of whom are no longer with us. And it's important as scholars that we always remember that. Secondly, I've been struck by the broader engagement and presentations of the 3 days of the seminars which we've witnessed here today. Once the seminar was largely attended and presented within by academics from universities. We've seen an increasing catch with people from the broader public, from students, which of course are the next generation of scholars to work in this amazing region. And also we've seen increasing engagement with the private sector in heritage research, which is critical development for the future of our discipline. Lastly, and I don't want to keep you any longer, Z&M was extremely happy to welcome you and to open our doors to all of you over the last 3 days. But perhaps of more importance is the fact that we have programmatically opened the door in the Seminar for Arabian Studies by bringing it to the Arabian world for the first time. Therefore, I look forward to seeing all of you again at the seminar in the future, sometime, somewhere in the Arabian Peninsula. Thank you very much. Safe travels.